of different topics of CYSA. It's totally free, so if you have a LinkedIn account,
Yeah.
you can go ahead and look at that. So let me bring that up. Hold on a second. Yeah, it is the certification prep. Okay. It's a little more than 20 hours, but don't have to listen to the whole thing. There's a lot of different topics in there. Okay. So if you want to go through there, it could target the topics that may be of some use to you while you're studying. They also have, again, A+, Net+, Security Plus. These are free classes. This is from the InfoSec Institute. Talk about threat hunting, governance, vulnerability
On the
management,
LinkedIn website? I
threat
didn't see
detection.
that.
So everything in the topics that's here too. All right. So take advantage of that as well. All right. Cool. All right. I looked at everybody's grades yesterday. We are still flowing, doing a good job. Whoop, let me go back here. All right. So we do have our last part of week 3 of CYSA, which is skills learned. Skills learned. Things that you can put on your resume, things that you can speak to. Just want to go over these last couple of bullet points for you. Again, this is something that was created out of the students asking, man, I know we're learning all of this stuff, but what are some of the common questions that they ask pertains to this job? So I can get ready for an interview.
Yeah.
All right, just common questions. We went over week 1, 2. Now here we are with week 3. As we can see here, some questions that you'll see, or let's just say bullet points that you'll see on the job application. All right. You may see, they may ask, you need to analyze digital forensics techniques to acquire and analyze digital evidence to ensure data preservation, integrity, and the chain of custody. Now, when we see this as a bullet point on a job posting, what things can you think about when we're looking at this? When it's talking about analyzing digital forensics techniques to acquire and analyze digital evidence, what are some things that you can do? If I'm an employer and I'm asking you that, say, are you familiar with digital forensics techniques? If so, which ones? Okay, Kevin says right blocker. I would agree with that as well. Chain of custody, Kevin says. I would agree with that. Gotcha, Mr. T. What else you got? Hashing. Really good. Faraday cage. Okay. So those are some techniques. Now, how would you acquire and analyze? You're correct. Everything has to be on legal hold for you to do this stuff in order to start a case, right? Case information. Let's not forget autopsy. Autopsy is one of those programs you can use in Kali Linux to start a program. It's one of many. Okay, so that's not the only one out there, but it does help. How are you going to acquire this digital evidence? Ma'am, sir, since we're in the interview room, what are some things that are important to you when you are acquiring any digital evidence and need to preserve it? Like, what are some first things you need to do? Okay, well, it's integrity, yeah. Mr. T says hardware, like HDD, SSD, take snapshots. Okay? Are you just doing backups, or is there a certain procedure that you have to follow when you first pick up an endpoint and the data in there needs to be preserved? Like, what are we doing? Like, how are we preserving it? Remember, I push y'all to the limit. I don't want the common answers. Let's dig a little bit.
How are you guys doing? Morning.
Okay, so the hash comes before the copy or after the copy? There you go. Make a copy of everything. Charles tags on there. You have to hash the copy for its integrity. What about memory? Yes, the order of volatility. Take that too. There are some programs out there that you can snatch the memory out of a computer, what's in the memory, including the CPU and the RAM. However, it's a little risky.
What is it that you guys have? What is it that you guys
you need more than what's on the hard
are interested in having conversation about?
Because if you do the RAM, you can crash the whole computer and you get nothing. So some of the things you got to think about, just for further thing, gathering history or documentation as well. You're correct. And then with that, that ensure the data preservation, because y'all already mentioned the chain of custody. The hashing gives you the integrity and saving it and locking it away. And there you go. Next, I'm acting as the employer. On the bullet point, you answered the call to the job application, but I need you to deploy scripts to automate some routines. What can you make easier around here? I'm Big Sugar. I got my record company. I got 50 computers. The last IT person quit because they say it's too much. I got wires everywhere. I mean, how you going? What's going on? One computer works one day, one don't work the other day. What can you do to help me get my stuff together around here with scripts?
You said Trump 2028. I am not particularly.
Big Sugar got to keep those masters. Yeah.
Politic guy.
Artist broke. I mean, I gotta stay profitable.
So there's not much input that I would have there, whether or not that's what it should be or not.
Restarts, yes, you can do some automatic restarts.
But if it's anything concerning the personal development of each individual, then that I have insight and input on.
Issue in what computer has a lot of uptime. I like that. Did I see somebody in here say logs too? Sometimes you got to delete cookies and clean out stuff. Yeah, that's common stuff. Then you analyze the security data. Where am I analyzing security data at inside of a computer? Right, because uptime on the computer can kill productivity if it's up too long and it's not getting updates. The dashboard, system monitoring dashboard. And of course, you'll go through with your IT team to streamline any processes. 3 more to go. All right, here we go. I'm the recruiter. Tell me about the time you had to analyze coding practices and you had to make it better and you had to secure the software applications. Tell me about that a little bit. What do you have to do? Okay, implementing code signing. I'm a recruiter, really don't know what that means. What's that mean? NCICD. All right, I use input sanitation to have standards of coding procedures. Love it. What else? Remember, I'm a recruiter. I really don't know. They just hand me this stuff to see if you fit the job. And I'm looking at what they tell me you should be answering. Alea says it's a digital signature that tells who wrote the code. There you go. See? There you go. That's what gets you, this gets you a greater chance of getting hired. You understand what I'm saying? You're not just spitting IT words out. They be like, okay, You can say, no, that's actually code signing. It's a certificate that's put in there. Keeps track of whoever updated it. Oh, now you got my attention. Charles says you're a bad recruiter. I just don't push you through to the next level. Kevin says continuous implementation and continuous delivery maintain security up. You love it. Or just do a peer. Oh, Mr. T says, hey, Mr. Recruiter, or I would just do a peer review with another colleague and see if they see a flaw in my code. Love it. Elaine says, look for inconsistencies in the coding or DNS. Love it. Leah drops on there, SAST is a static code analysis. Love it. Look at y'all. Listen, for that, y'all get rockets. Rockets today, early on. All right, did I miss anybody? Continuous. Okay, everybody answered. Thank you. That was a great answer. Next. Mr. Miller, can you give me a chance to assess this authentication protocols and tools to secure I have a secure system? What are you doing there? Tell me when you had to assess authentication protocols and tools. Was this at your prior job?
Wait,
were you successful, sir? See, I'm gonna spit out some words. Shut up. Oh, also Kevin says run a debugger periodically. Well, actually, as a matter of fact. So how are we gonna assess so you're brand new. I would like to hear what the first thing you would do, because this is a perfect way for you. When they say assess authentication protocols and tools, this is a perfect way on your first day at a job where you will walk around to find on your first day at a job. See, this is a setup question. This is a question where it's not what you would have done after being here for a year.
Yeah.
It's like, well, when you hire me, first thing I'm gonna do is walk in and see what and look for what. I'm gonna assess what. Bingo. As a matter of fact, basic authentication, I have to protect that. I'm looking for written passwords on sticky notes on desks. What else? I'll run an nmap ahead. Yep, got to make sure I don't run an nmap. Unless permission from the supervisor, it may shut down the server because you might have a prevention system. Walk around and see what cables are out, passwords are out, clean desk policy. I will walk around and see what your physical security is, because if your physical security is trash, then somebody getting to the network is even worse. You get what I'm saying? That's a perfect segue to say, I don't know what your security looks like. I would have to see it. But when I walk in, this is what I'm looking for. Shady dudes. Yep, people with hoodies on. Like Slim, yeah. Charles says also using printer rules, secure print. Like charging phones on unauthorized thumbs. See, this is just basic stuff. You don't have to go way into detail like you're a brainiac. Just be like, listen, first thing, I don't know what your system looks like. Second, if I do walk in, this is what I'm looking for. Okay? Then the last one, that's Army rules. Use patch management tools to mitigate and secure systems. All right? Good time for you to use the spit some knowledge about Windows OSs. When do they usually update? Charles says the OS with security patches scheduled for tonight. Yep. So first thing you do is say, well, I have to figure out what the newest update is. I'd audit a couple of your computers. See what build you're on, 2H2 or 2HL or whatever it is. Love it. I'd go from there, because Windows usually sends a quarterly update and then an annual update. Make sure it's logged. I walked around every piece, every component. Schedule. firewall, schedule downtime, work with the team. During working hours, I look around. After hours, I schedule an update. Everybody gets an hour break. Oh my gosh, I fell into that one. But yeah, so you'd be like, okay, I have to figure out where we're at in order to know what patches you may need. Perfect way to use that to say, when's the last time you patched your systems? I don't know. Well, I'm in the same boat. I wouldn't know until I got there. See, a lot of this stuff, this is what the answers that they look for are these types of things. How would you use patch management system? Well, I wouldn't know because I'm not at your job yet. Like, what routers do you use? What switches do you use? How old are they? These are all unseen things, but these are things I would look for and log in and see what the firmware is. Do you know the last time? And then when you hit them with a question, do you know last time your stuff was updated? Well, actually, no. Oh, well, how do you expect me to answer that question? You know what I'm saying? So it's cool to use a redirect question if they ask you a question like that. It's just the way you have to say it, okay? But this also gives them a sure footing of all networks are made differently. Some questions you can't answer until you get there. I could spit all day what I could do, but it really won't even help you if it doesn't apply to your technology. Yep. So good job. All of y'all are hired. I'm hiring Brian. He has to bring the drone with him now. He has to fly at lunch. Okay. So that's some good stuff. No fly zone. Y'all good with that? But make sure y'all download that document. Charles says I'll be calling you before an interview. Yeah, give me a call. Let me know you calling though, so if I'm teaching, I can take a break. Oh, I got Charles calling.
Yeah.
All right. So it's good stuff. All right. So at the top of the hour, we'll go over domain 3. Domain 3. So I'll let you get some work in beforehand. Yeah, we're doing Jeopardy at 11.
The management of the company to step through simulated problems and describe what they would do in those particular situations. This means we don't have to go through the physical process of going to get our backups and taking them to this remote location, but it does require that everyone step through the process and see all the logistics are in place to get that data from one location to another. Since we're all sitting around a conference room table to be able to describe the process that we would follow, we refer to this as a tabletop exercise. This is a meeting that you can go through in about a day or two, and all the key players will be participating and stepping through the process that they will follow if a disaster is called. There are some organizations, though, that go through a full-blown disaster recovery site either once a year or multiple times a year, So it's always good to go through these validation tests. That way, if a disaster occurs, everyone in the organization will know exactly what to do. When you're running through these validation tests, you're obviously not actually moving from a production environment into your disaster environment, but you are going through exactly the same process. Usually these validation tests will follow a particular scenario. For example, let's say a fire was to destroy the building where your primary data center existed. There would be a series of processes and steps to be able to move everything to the disaster recovery site. But what if the scenario was different, where everyone in your geographic area around that data center had to be evacuated? In that situation, there might be a different set of steps to be able to get all of your applications and all of your data from your primary location to that backup site. Once everyone steps through this scenario and goes through the entire disaster recovery test, we can document what worked and the things that need to be fixed for later. This allows us to make ongoing improvements so that we know exactly how to be more efficient when moving everyone to a disaster recovery site. Maintaining uptime and availability on the network can be a challenge, and in this video, we'll look at different methods for providing that network redundancy. One of the most common forms of network redundancy is active-passive. This is where you would have two separate pieces of equipment, but only one of them is active or running at any particular time. These two devices are constantly communicating between each other, giving updates on their status. And if the primary device fails, the secondary device takes over as the primary device on the network. This means the configuration between these two devices needs to be identical, and if you make a change to the configuration on the primary device, it needs to copy that configuration to the secondary device. You also need to make sure that any real-time information is updated between both devices, so if there is a session table or a routing table, all of that information also needs to be copied and maintained on the secondary device. That way, if the secondary device does become active, it has exactly the same configuration as the primary device did. Visually, this is how it would look on a network map. You have an internet provider, let's say our network connection out to the rest of the world. There are two firewalls in this configuration, and behind the firewall is a router, a switch, and a web server. In this case, these two firewalls are running as an active-passive configuration. One of the firewalls is active, and the other firewall is in a standby or passive mode. When traffic is sent through the network, that traffic passes through the active firewall to the web server that's on the other side. But let's say that primary firewall had a problem. Perhaps the power supply failed, maybe the software crashed, but something within that device has caused it to go offline. This means that we now have no available firewalls on our network. But of course, our passive firewall has been in constant communication with that active firewall and recognizes that it's no longer on the network. So the passive firewall now makes itself into an active firewall, and it becomes the primary device on the network. So now any future communication on the network uses this new firewall to be able to complete that communications path. You might be looking at that network design and think you've purchased two firewalls, both of them are plugged in and they're powered on at the same time. Why don't we use both of those firewalls simultaneously and take advantage of all of that extra computing power? Having both of those devices operating simultaneously is referred to as an active-active configuration. However, simply turning on both devices and running traffic through both of them is not always a simple task. There's usually a bit more engineering required to make sure that you can turn on both of the devices and use both of them simultaneously. For example, you might have data flowing through the network in different directions. Maybe one part of the conversation goes through one device and the return part of the conversation goes through a different device. You need to have some type of mechanism that keeps track of all of these different data flows and what device they're flowing through. This often requires a good bit of design work and understanding of exactly where the traffic flows are in the network, how the routing is configured, where the switches are located, and how you would expect traffic to flow on a normal basis. And as you would expect, with an active-active configuration where both firewalls are operating simultaneously, you can send traffic through the network, and one traffic flow may go through one of the existing active firewalls, And a secondary traffic flow may go through the alternate or secondary active firewall. If one of the firewalls was to fail, you don't have to worry about failing over to a secondary because both firewalls are already active. The other firewall that's remaining will continue to handle the load and traffic will continue to flow normally through that network. On our modern networks, we've become so accustomed to simply turning on our systems and we're able to communicate with other devices on our local network or browse the internet. But it wasn't always this easy. We used to manually configure all of our IPv4 configuration settings, the IP address, the subnet mask, the DNS settings, and everything else associated with TCP/IP was all configured manually on every device. In order to scale this process, we created a new protocol that would do all of this for us automatically. This was called the Bootstrap protocol, or BootP. But BootP didn't configure everything automatically, and there were a number of enhancements that we would like to make to the protocol. For example, if someone left the network, it would be nice if this protocol recognized that that IP address was now available. So we created a newer version of BootP called DHCP, or the Dynamic Host Configuration Protocol. DHCP is the protocol we use today to provide these automatic address configurations for all of the devices on our network. The process for defining these IP addresses automatically follows 4 different steps that we're going to call DORA, D-O-R-A. The D stands for Discover, where there is a discovery process where you find the DHCP servers that are on your network. The next step is the offer phase, where we get an offer from a DHCP server. The third step is the request process, where we request one of the offered IP addresses. And then lastly, we have the acknowledgement phase, where we tell the DHCP server that we have received that configuration and are using that particular IP address. Let's step through all 4 of those phases from the perspective of this network diagram. On this diagram, we have Sam that has just connected her laptop to the network, and she needs to receive an IP address. On her local subnet, you can see there is a single DHCP server, and there are other devices on this network that we're simply not showing in this particular diagram. There's also a router, and this router is connected across a wide area network to another router, where there's a separate switch and another workstation that is owned by Jack. Let's focus on the process that Sam is going to use to obtain an IP address. This first step is the Discover step, and in this step, Sam's workstation is going to send a DHCP Discover packet. It's going to be sent from an IP address of 0.0.0.0, because Sam's workstation currently does not have an IP
Good.
address.
Just gonna kind of, zone in and do some last minute course study.
255.255.255.
Need something, let me know.
This is sent as a
Thank you, sir.
broadcast so that every device on the subnet will see this DHCP request, and if the device happens to be one or more DHCP servers, those devices will be able to respond back. You'll also notice that this request is sent using UDP port 68 on Sam's workstation, and the broadcast is sent to UDP port 67. This packet is sent from Sam's laptop, and because it's a broadcast, it's sent to all devices on this local subnet. The DHCP server will see that broadcast, and it will send a DHCP offer, which is step 2 of the DHCP process. This DHCP server has an IP address of 10.10.10.99, and it will send this with a source port number of UDP port 67. Notice that the DHCP server is going to send this as a broadcast. Send it to 255.255.255.255, and it's going to send this to a destination port number of UDP 68. This is obviously being sent as a broadcast because Sam's workstation currently does not have an IP address. The only way that Sam's device would see this packet is if it's sent to all devices on the subnet. This DHCP offer will be sent from the DHCP server and broadcast to all devices on the subnet. If there were multiple DHCP servers on this network, Sam could potentially receive more than one offer from a DHCP server. So in step 3, Sam's device is going to choose one of those offers and send a DHCP request to that particular DHCP server. This request is obviously coming from 0.0.0.0 because Sam's workstation still does not have an IP address. It is sourced from UDP port 68, and the destination is going to be 255.255.255.255, another all ones broadcast, and it's being sent to a destination port number of UDP port 67. This traffic flow is very similar to that first Discover traffic flow, where all of the packets are broadcast to all devices on this local subnet. And the last step is step 4, or the acknowledgement. This is sent from the DHCP server back to this device, acknowledging that it has received that request. The acknowledgement is sent from the DHCP server, in this case 10.10.10.99, with a source port number of UDP port 67. And again, it is sent to a broadcast address, 255.255.255.255, with a destination port number of UDP port 68. And again, this will go to all devices on the subnet, but obviously the only person waiting for that acknowledgement would be Sam's device. Now that Sam's laptop has received the acknowledgement from the DHCP server, it can now configure all of the IP settings automatically for Sam's laptop. As you may have noticed from that network map and the different phases that we went through with DHCP, there is a significant limitation associated with the DHCP process, and that is the broadcast that is being sent by the different devices. Broadcasts, of course, are only transmitted to your local subnet, and none of those broadcast frames will traverse a router. This becomes a challenge for an enterprise network where you'd like to have redundant DHCP servers and ideally have those DHCP servers distributed across different parts of the network. Fortunately, there is a way to implement DHCP in this environment by using some additional features of your router. We also might want to centralize these DHCP servers instead of having separate individual DHCP servers that are scattered across every remote site that we might have. Fortunately, many routers support a way to enable DHCP across these different subnets, even though DHCP uses broadcast to communicate. We refer to this router functionality as a DHCP helper or a DHCP relay. This will allow you to send DHCP traffic to another subnet, even though it's being sent originally as a broadcast. We would first configure a router with a DHCP relay configuration. And in that configuration of the router, we would specify that there is a DHCP server located at 10.10.10.99. And that is our original DHCP server that we were working with earlier. In this scenario, Jack would like to receive a DHCP address, but as you can see, there is no DHCP server on Jack's local subnet. Jack's laptop doesn't know this, however, and it will simply send the normal DHCP discover message out to everyone on this local subnet. When that broadcast is received by the router configured with DHCP relay, it will look at its configuration and realize there is a DHCP server at 10.10.10.99, and it will relay that information to the DHCP server. It changes the source IP address to the IP address of the router, in this case 10.10.30.1, and it changes the destination address to the IP address of the DHCP server. It effectively takes what was a broadcast and turns it into a unicast communication. This packet can now be sent across the network to a DHCP server that's located on a different subnet. The offer process works exactly the same, but in reverse. The offer leaves the DHCP server and is directed with unicast to the router's IP address at 10.10.30.1. At this point, the relay modifies this back to a broadcast and is sent to the local subnet with an all-ones broadcast. This process repeats for the last two phases of the DHCP process, and that allows Jack's workstation to receive an IP address even though the DHCP server may be on a completely different IP subnet. In our previous video, we looked at the process of DHCP from the client's perspective, but obviously there are a number of configurations that have to be made to the DHCP server itself. So in this video, we'll look at some of those DHCP configuration settings. When a device requests a DHCP address, the DHCP server refers to a list or pool of addresses that are defined within a DHCP scope. This scope commonly includes the IP address range that will be handed out to the different devices on the network, as well as any addresses that should be excluded from the DHCP pool. You also have your subnet mask as part of this scope. There are also lease durations, so you know exactly how long these IP addresses will be available on that device. And there's other options that you might include, such as the DNS servers that need to be configured, default gateways, and other additional optional settings, such as voice over IP server IP addresses. There are usually a pool of IP addresses created on a per subnet basis, and each scope usually is responsible for providing that particular subnet's IP addresses. Usually this is a contiguous pool, so you can tell the DHCP server to assign addresses 1 through 100 on this particular subnet. And then if you want to create exceptions to that, you can add them to the scope as well. Here's what this looks like on the server manager on Windows Server. This is part of the DHCP server settings, and this particular DHCP server handles the network sg1.sgc.local. You can see there is a single scope available on this network. Its scope is 165.245.44.0, and within that scope you have a pool of IP addresses that would be handed out, the address leases, any reservations in this IP address range. Reservations are for devices that will always receive the same IP address each time it is requested, and then scope options that you might include along with others on this scope. So if you need to make changes to the IP address pool or modify any of the DNS configurations or anything else associated with DHCP, you would do that all from this DHCP settings inside of this scope on the server. This process happens automatically for the end stations. They make a request to the DHCP server, and the server goes through the pool of addresses, picks one of those addresses, and hands it out to that device on the network. There's a lease period associated with this address, so that device is able to use that IP address for only a limited amount of time. And if that lease is not renewed, that address is then returned to the pool, and someone else visiting that network can potentially be assigned that IP address. An interesting feature of DHCP is that it will keep track of these MAC addresses and IP addresses that it's pairing together. So if you visit this network again, the DHCP server will recognize that you've been here before. And if the IP address you used previously is still available in this pool, you will be assigned the same IP address you had on your original visit. If you wanted to configure an IP address on a printer or a server, and you wanted to confirm that that IP address would never change, you could manually configure those settings on that device. But this does not scale very well, especially in large networks, and if you need to make a change to those settings, you would need to manually visit all of those devices to make that configuration update. Instead, you might want to lock in the IP addresses for those devices in the DHCP server using a feature known as address reservation. Inside the DHCP server, you would create a table that has the MAC addresses of these devices, such as your printers and your servers, and you would manually configure an IP address within the DHCP server that will always be assigned to that particular MAC address. If you look at your DHCP server, you might see this listed as static DHCP assignment, static DHCP, or an IP reservation. Here's the address registration process in one of my DHCP servers. This one has a couple of reservations that I've added. This one is 192.168.1.6. The device name is Prometheus, and you can see the MAC address of that device is listed in the reservation. I also have another IP address, 192.168.1.9. This is the device known as Odyssey, and it has, of course, a different MAC address. By adding these addresses into the DHCP server as a reservation, I can go to one central place to manage all of this information, yet still be assured that those devices will always receive the same IP address every time they're started. As we mentioned earlier, these DHCP addresses are not permanent. They are leased to these devices, and they're only available for a temporary amount of time. This lease time is one that is configured in the DHCP server itself. In some organizations, they might have a very long lease time. In other locations, it might be very short. You as the DHCP administrator get to determine what the lease time will be for your network. If you were to look at the IP address configuration of your device, you would see the lease timer associated with the IP configurations. If you were to restart that device or unplug from the network and plug back in again, you would be reinitializing that DHCP process and potentially restarting that lease. Another nice feature of DHCP is if you are turning off your system, it can release that IP address back into the pool so that other people would be able to use that IP address in the future. This DHCP leasing process doesn't wait until the entire lease is complete before trying to renew the lease. Instead, there are different timers that DHCP will use to be able to provide that renewal. The first timer is a T1 timer. This is set by default as 50% of the lease time. So no communication is going to occur between your device and the DHCP server until half of that lease is complete, at which time your device will attempt to communicate to the DHCP server and renew the lease. But it could be that the original DHCP server is no longer operating properly or has been removed from the network. In that case, we go to a T2 timer. By default, the T2 timer is 87.5% of the lease time, or 7/8 of that lease time. With the T2 timer, your device will attempt to renew the lease with any available DHCP server that's on the network. Let's say on your network that your DHCP server is set with a lease time of 8 days. If we do the math, that means the T1 timer, since it's 50% of the lease time, would be 4 days, and the T2 timer, or rebinding timer, would be 7/8 of that time frame, or in this case, 7 days. So under normal operation, we'll go along for 4 days without needing to check in with the DHCP server. But as soon as we hit that T1 timer, we're going to begin a period where we will begin renewing with the original DHCP server. So that renewal is sent to the server, and if that DHCP server is available, it will very quickly renew that lease, and we'll have another 4 days where we can continue to operate without checking in again with the DHCP server. But let's say at this point, that DHCP server is taken out of the network and is no longer available.
That's actually a good
That means
question,
we'll
Mr.
go
T.
all the way through the renewal period without ever
I
renewing
would.
the lease.
Like if I'm looking at a
Once we
system
hit
and
the
something's
T2
off,
timer or the rebinding period,
I would
your
restore
device will
on
reach
an
out to
alternate
any
host or a
DHCP
computer
server to
the
try to renew
backups
that
from
lease.
that
And on
computer
your
to see
corporate
what
network,
changed.
there's most certainly another DHCP
Yeah.
server, and it will renew that lease, and the entire timing process starts over again. We often think of DHCP as that automated IP address, subnet mask, and default gateway configuration, but there are other options that DHCP can configure as well, and we refer to those literally as DHCP options. This is a separate field in the DHCP process that allows us to configure other settings that are related to TCP/IP. These options are listed in the request for comments, or the RFC associated with DHCP. Back in the BootP days, we refer to these as vendor extensions.
Yeah.
These DHCP
The
options
one thing
are
is
associated
what you
with
want
the
to
number, and there are 254 usable options that could potentially be
and
configured
I would work my way
using
up. To
DHCP.
be perfectly honest, Mr. T,
The
like I'd
common
probably go back 30
configurations
days,
of DHCP would be the things that we would normally think
or as far
about.
as I
The
could
IP
go,
address,
load
the
it,
subnet mask, the default
check the
gateway,
logs,
and
load
the
a
DNS
newer back
servers.
up,
And
check
there
the
may be
logs,
times when
load
you
a
would
newer
like to
back
have
up, like,
additional
you know what I mean?
DHCP
Systematic.
options to be configured on that device, but you have to make sure that the DHCP server supports that specific option. Not all DHCP servers
You'll run your
support the ability to configure
vulnerability
DHCP
assessment
options.
programs
So
and
you
all
want
that
to check
stuff on
with
it,
your
as well
DHCP
as you're
server
going along.
to make sure
Yeah.
that the options you need are supported by that server. For example, you might have a voice over IP call server on your network, and you might want to add that as part of the DHCP configuration process. So option 129 is the DHCP option for the call server IP address. If you wanted to configure an HTTP proxy, you would use option 135, and there are many other DHCP options to choose from. We're looking again at the scope that's configured within Windows Server under the DHCP server options, and there is an option there for server options, and that refers back to those DHCP options. You can see a list of all of the numbered options within those server options. You can select any of those and define them within the DHCP server itself. Then when anybody connects to the network, not only will they receive the IP address, subnet mask, default gateway, and DNS settings, they'll also receive any of the configurations that you've defined under DHCP options. With IPv6, we've taken a number of techniques we've used with IPv4, and and we've updated them for the modern network. Of course, there's DHCP for IP version 6. Those DHCP servers use a very similar process to what we saw with IPv4 to assign IP addresses with IP version 6. This uses redundant DHCP servers, so it's ready for the enterprise, and you as the DHCP administrator will be managing this DHCP version 6 server as well. But unlike IP version 4, IP version 6 can assign an IP address to itself and be able to communicate with anyone on the network. We refer to this as stateless addressing. There's no DHCP server that manages the process. You don't have to keep track of IP addresses or MAC addresses. And with this stateless addressing, there's no lease time, so you never have to worry about giving up your IP address. An important protocol that's used for IPv6 stateless addressing and other purposes is the NDP protocol. This stands for Neighbor Discovery Protocol. In IP version 4, we use the Address Resolution Protocol, or ARP, to be able to find other devices on the network. But ARP requires broadcasts to be able to operate. With NDP, we're using multicast, so the overall communication is much more efficient. The way that an IPv6 device is able to effectively assign itself an IPv6 address is using Stateless Address Auto Configuration, or SLAC. You don't need a DHCP server. The device running IPv6 creates its own IP address to use. One of the concerns we obviously have is that if a device is creating its own IP address, it could potentially conflict with an existing IP address on the network. But in IP version 6, we have Duplicate Address Detection, or DAD, and it checks to be sure that there are no duplicate IP addresses on the network. Neighbor Discovery Protocol can do more than simply find other devices on your network, can also identify routers using the router solicitation and router advertisement features. If a device wants to find a router that's on its local subnet, it uses this Neighbor Discovery Protocol and uses the router solicitation feature and sends that to a multicast that says, if there's any router out there, please respond back. And if a router sees that multicast, it will send a router advertisement directly back to that workstation. Routers can also send their own advertisements out without being queried. We refer to those as unsolicited RA messages. They're sent to a slightly different multicast location, and they're sent to all of the devices on the network that might be interested in knowing where routers exist. This router advertisement is useful because it can provide information about the local subnet. Things such as prefix values, prefix lengths, DNS server configuration, and other IPv6 configuration parameters. So here's how SLAC, or the Stateless Address Auto Configuration, works with IP version 6. The first thing your device does is determine what local subnet am I on, and it does that by using the Neighbor Discovery Protocol and asking a router through the router solicitation feature, what subnet is this?
All right, Mr.
The router will
Elaine,
respond back
I
with a
sent you
router
an email.
advertisement containing that information. For
Sent
example,
you an
we
email.
can query the
You wanna check
router
it real
using
quick?
this
Okay.
Neighbor Discovery Protocol, and we'll receive back this 64-bit IPv6 subnet prefix. You can see an example of that is
As
listed
promised,
here.
10
But of course, that's
she'll
only
be over
half
10 minutes,
of the
so we're gonna break.
IPv6 address. We
This
also
is
need what's
the
known as the
power
last 64
of a
bits, or the interface
CYSA
ID.
review.
Many devices will take a modified version of their MAC address,
could be
put the
used.
letters FFFE in the middle
I'm about to show you
create
what they call
64
a
bits that
test
they can
bank
then use
review.
as the last part of the address.
And they
Other
go through a
devices will
couple of
simply
questions that
randomize
you may
this
see
value to create
on
those
the
last 64
exam.
bits. And just to make sure that this random value or the value associated with the MAC address doesn't somehow already match an
tonight's
IPv6
test
address on the
bank
network, the Neighbor Discovery Protocol is used
is
again.
going
It
to
uses a feature
have,
called Duplicate Address Detection, or DAD, and checks the rest of the network to be sure that no one else is using that
simulations. We'll go over
specific
simulations.
IPv6 address. Now
All right,
that the stateless
just
address
to look
auto
through it.
configuration process is complete, your device
Question
now
one is
has a
purple team.
completely routable
You have any
IPv6
questions,
address
stop me.
that is unique to that
You
particular
want
station.
to start checking for vulnerabilities in the design of SQL injection, cross-site scripting. That's done through dynamic testing. Number 3, we've changed business continuity disaster. What's the best way
One
to
of the most
test
common
changes
uses
able
of DNS, or the domain name system, is to translate the names that we put into our browsers.
Next up,
into
reverse
IP
engineering
addresses
is
that can
how
be
we
used to connect
recover
with that particular
a
server.
binary
For example,
file
if you put into a browser
that understands its purpose.
www.professormesser.com,
Number 5,
there's
cross-site
no
scripting.
IP address associated with that
You're no
name.
longer able
There
to
needs
log
to be
into
some
account after
process to
browser
resolve
update.
the
But we
IP
have several
address
tabs
based on
open.
that name, and
We're
we
learning
rely
that
on
several
DNS
tabs
to
open
provide
points
us with
to
that name
cross-site
resolution.
request
This
forgery. We
database
talked a
of
lot
names
about
is
that
a hierarchy,
yesterday.
and in this video we will look at the structure of the DNS
Deregistry
database. We
contains
often
keys
describe
and
this resolution
values.
process as one device that is
Okay,
receiving
right here,
information
keys and
from one
values.
DNS server. But in reality, there
Yes,
are many
question.
DNS servers. In fact, the root
This is
DNS
the test from
servers
yesterday,
consists
right?
of 13
The-
separate server
Oh, so
clusters
it's not
that
today?
make up
It's-
over
okay.
1,000
Oh, no, I
actual
just posted that
DNS
for you to
servers.
download. Y'all study
These
that
DNS
tonight.
servers
Oh,
manage
okay.
the top
I'm gonna,
level
yeah,
domains.
I'm just
or
sort of reviewing what we looked at
TLDs,
yesterday
of a
real
number
quick.
of different generic
Okay.
top levels,
And I think we
such
got
as
through
.com,
25.
.org, .net, and others.
Just
There are
see if
also
anybody has a
country-level
question.
TLDs.
Geolocation is how
Those
you would
are
block
country codes
from
such
another
as
country.
.us for the United States, .ca for
Risk
Canada,
register is a
.uk
tool
for
that
the
tracks and
United Kingdom,
mitigates
and
threats
so
and
on.
vulnerabilities and the
Here's an
impact.
example of a DNS
of
hierarchy.
risk,
This starts at the very
vulnerabilities.
top of the tree, which is a single
Beaconing is
period
where
or
you
dot.
have
Underneath that
an
is the top
internal
level
host
domains, such as
communicating with an
.com,
external
.net,
server.
and others. And then you can
That's a
have
beacon.
other names underneath those, such as
Well, we looked at this
Professor Messer.
yesterday,
For example, you
and
could
this
have
is local file inclusion that
www.professormesser.com, all found by
directory traversal
following
to do
this
that.
hierarchy.
But
We
we
refer to
directory
this as a
traversal
fully
to the
qualified
access.log
domain name, or
file.
an FQDN. You can structure
The rest
the
of it's a
names used
distractor.
in your organization into this FQDN
Here's
model.
where we have
For
a primary
example, you can start
control
with
to stop access.
ProfessorMesser.com,
It's
which
a
incorporates
database,
everything
but
within our domain.
we discovered an
Underneath that
authentication
name, you might
vulnerability,
have
so now we need to employ additional layers of access
www.professormesser.com,
controls.
which is the fully qualified domain name of our
Number
website.
12, we have a
You can
vulnerability
continue to add on to
scanning,
this domain
and
name. For example, in our organization, there is an east and a
it's highly
west for the
segmented, so
domain
therefore
names.
you're going to
And
use
within the
agents.
east, there might be servers and services.
That's how I sort of
with
read
names
these questions
associated
after I
with them.
know them.
And in the west, there might be a separate group of services in that particular
What's the
area
goal
of the domain.
tabletop? To look at incident
We use
scenarios and
DNS
how
to
to
resolve the
properly
IP address
react.
of many different services. For
This,
example,
where
a
the
web server
timestamps
would
are
be a
very
very
close
common
together, but
resolution.
anyway,
But we also use this for things such as
it's not a
directory
great
and
question,
for
but out of
application
ABCD, this is
access.
a vulnerability
To be able to
scan.
maintain uptime and
It's not
availability of such an
escalating
important
privileges,
service,
it's
we
not
will
a
often use
password
redundant
hack.
DNS servers. This means we might have 2 or more DNS servers, and we can configure
That's
our
what it is.
systems
And
to
here's
use
Geo-
those redundant
Geo
servers.
IP
So
look
that if
at,
the
you want a
first
shell
server is not
script to
available, you still
identify
have another
country
server to
addresses.
choose.
You
You'll
can do
notice
that
if you look
through
at the configuration of your
GeoIP
computer,
lookup.
there are usually 2 DNS
We
configuration
can't
settings.
update an
This first
appliance
one is
because
for
it
the
belongs to
primary
a vendor.
DNS server. This is a DNS server
So
that has
therefore,
all of the zone information
It
for your
represents
particular
the
DNS domain.
vulnerability as a
Any
proprietary
changes you
system.
make to the
We don't have.
configuration
We just
or
want everyone
updates
to.
to the config all happen
Yeah,
in
this
this
test is
primary
pretty lined
DNS
up to the
server.
book. I'm pretty
The
impressed
secondary
actually. The other
DNS
ones are
server
not.
is not used for primary configuration changes.
Reconnaissance.
Instead, it
You
receives an
find
update from the
external
primary
IP
DNS
addresses
server.
that are
All
running
of the zone
network
information
scans.
is pushed
They're
down to the
doing
secondary
recon
server
only.
in a read-only
Several
mode.
tabs
And
open on the
anything that
browser
we
again.
get from
Cross-site
a
request
secondary
forgery.
DNS server was first configured on the
Deweaponization.
primary DNS server. From the end user's perspective, of course, it doesn't matter
Okay,
which
now,
DNS servers,
I'm gonna pause it real
the
quick
same
just to say
information exists in both of those.
They do this
And
too for
regardless
A+.
of which server was
Net+.
accessed,
This
the
is
end
a
user
tool
has
I
no
introduced
idea if
early
it
on
came
in
from
the
a primary
whole
DNS
course.
server or a secondary
That
DNS
LinkedIn
server.
is the truth. These are the
In some
experts going through.
situations, you
Wow.
might not want to query
Also,
a
what you
server
see
to
is
provide
you
that
see
name
actually how
resolution.
big these questions
Instead,
are
you
going to
might
be.
want all of that
Possibly.
resolution to occur on your
Possibly.
local machine. We refer to
Right.
that as a
So
local
it's showing
name
you
resolution. For example,
how
if you
big
have a
they-
test server, you might want to
they may
configure
be.
your system
So,
to
yeah,
access
something
this
good.
test
All right,
IP
final
address for that
They
server
compile and
rather than
test it unless it's
accessing the
downloaded.
production server itself.
And
You
they're
might
testing
also
it. What are
use
they
local
doing?
name
They're
resolution if you
gonna
feel that the
weaponize.
DNS server has incorrect information.
20
and
we
you wanna have
talked
your
about
own
yesterday is
resolution
either
that
the
corrects that
firewall or the
information
email
on your
header will
local
work. Don't worry
machine.
about it.
To accomplish this, we need a
21,
file with all of this name
this
resolution
is
inside of
a
it, and the
two-
file name is commonly called the host file,
Arachne,
because the name
I
of
think
the
it's like
file
that.
itself is called host.
I've never used it.
This
but
is an example
I
of
did a
the
little
host
research on it.
database.
Text
It's simply a
search is what
text
you use
file
to check
that contains
for
information about the IP addresses
And you
and
can
the
see, it's
names of
analyze
the
and
devices that
response
you would
and
like to
it's tagged.
resolve. For example,
That means
I
there's an
have a
issue.
test server for www.professormaster.com.
Number 22,
Its IP
somebody
address is 10.1.10.170,
opens up an
and I can
attachment
configure
from
my
an unknown
host file
source.
to access that IP address
There
every
are
time
an
I
insider
reference
threat, but it's unintentional.
www.professormaster.com. This works for many
Vulnerability
applications, but
management
there are
found
certain apps
four
that
major
will not
vulnerabilities
reference the
during an
host file.
assessment. It needs to
Instead,
provide a
they will
report
rely on the DNS
for the
server
proper
as the primary source of
prioritization
information. So
for
you want to
future
check the
mitigations,
documentation for your
which should
application
have
or
the
your
highest
browser to see how it resolves this information.
authority for the
That way
mitigation.
you'll know whether
It's
the host
related
file is something
to
that
a
can be used on
specific
your system, or whether you need to
adversary
configure
campaign.
all of those
That
settings
would be
on
an
the
APT
DNS server
attack.
itself.
That's
Here's
just
a
a different
bigger
way of
view
saying
of
it.
this host file
That's
inside of
true.
Windows. This file itself is
Next
located
up,
at Windows
IOC, possible ransomware contamination.
/etc/drivers/etsy/hosts.
What do you do next?
This is a
Well,
file
they've
that is often
identified it.
stored as a
More than
read-only
likely.
document. So if you want to make
Notice
changes
that
to
there's
this
no
file,
way to
you'll have to
do
first
perfect
change the file so that
identification
you
because
have
it's just
read-write
possible.
access.
I don't
And once
like
you do
that in the
that, you
test
can
question.
modify
Can
the
get
text
distracted.
within this file to have
But
the
if
IP
you know it's
addresses and
ransomware,
names
what do
that
we
you
do
would
next is to
prefer
contain
rather
or
than the
isolate.
ones that are located on a DNS server.
And next
One of the
up
most common
is
uses of a DNS
an
server
open
is
source
to provide
developer has
a
decided to
forward
sabotage a
lookup.
code
This means that
repository
we
with a
provide
logic.
the DNS server
Logic
with a
bombs
name
run on
and
time
it
and date
returns with an IP
or
address.
event.
For example,
They
we
have
can
created
send
a weapon,
the name
weaponization.
www.professormaster.com
All
to
right,
the DNS
disconnect
server,
the
and
access
DNS
point
server
from the
will respond
network.
back to
During
us
a
with
recent
the
site
IP
search,
address
you
associated
discover
with
a
that fully
rogue
qualified
wireless
domain
access
name.
point.
But we
your
can
network.
also provide this
Notice
entire
what
process
actions
in
should be
reverse.
taken
We refer
first.
to this
It's
as
an
a
incident.
reverse DNS, where we provide the
The
DNS
identified
server with
road
an IP
access
address,
point, what do you
and
do
the DNS
contain?
server gives us
In
information on
this
what it
case,
believes the
it
name
is to
is
disconnect.
for that IP. This is something that
Disconnect
will
it
need to
from
be
the network,
configured
first thing
in
you
the
do.
DNS server to provide
Now, once
both
you
a
disconnect
forward lookup
it, you
and
still
a
can
reverse
get to the
lookup. And
configuration.
you'll often find the
Then
name
you
that
bust
you use
into
for
it.
the forward lookup might be different than the name
Next
you
up,
receive for
quarantine
the
the
reverse
server.
lookup.
Again, during an
Here are the
incident,
results of a
you know,
forward lookup.
one of the web
I
servers
provided this
at the
lookup
perimeter
through a
network,
utility
that means
named
on the
dig.
internet,
This
was
dig
affected by
utility allows me to
ransomware.
query DNS
What do you do?
servers. I
Perform a
use the
dig.
dig utility with the
The
parameters
incident has been identified ransomware.
www.professormaster.com.
What do you do
It tells me
next
that it's
is
going to
to
perform this
contain.
query against the name server.
Here,
It shows me
contain
information
is
that I
the
have
best one
requested
is to
here,
quarantine.
such as professormaster.com. And you can see
You
that
know,
the results
the problem
in the
with
answer
shutting
section
it down is
show
you're going to
me
lose
3
everything.
separate IP
So that's not
addresses
the best answer.
associated with
Quarantine means to
www.professormaster.com.
segment it away.
These 3 IP addresses
isolate
are
it.
listed
That's-
here in this order.
So
And
again,
at the
that
bottom of this
formula
output, we
works
can
for
see how
incident
long it took
response.
to
Don't
perform the
forget that.
query and the DNS server that was referenced to provide
But this
the
one's
same
iffy.
tips. With this particular example,
I've
you
seen
can
a
see
lot
that
of these
there
on
are
Plus
3
Test.
separate IP addresses that
Here's an
can be
MX
used
scan.
to
It says
access
you audit for
www.professormaster.com. But let's
unsecure
perform a reverse lookup to one of these IP addresses and
services.
see what
Okay.
the name is that we get.
Well,
back.
what you're looking
To
at
perform a
is
reverse DNS
what are you
lookup,
gonna
I'm to use
investigate?
the
Well,
same
what I
dig
wanna tell you
utility,
is
but I'm going to use the option of
421 is
-x
a non-secure
and include the
protocol, it's not
IP address
encrypted.
of
However, the state reports close.
104.22.72.108. And if we look
We
down
have
further
423,
into the
which is
results that
filtered,
we
which
get,
means you actually
we can
can't
see
access
that
it, but it's
particular
clear
device
text.
is cruise.ns.cloudflare.com.
That is gonna be one that we investigate.
This is because the front end
Okay.
to the www.professormaster.com web server is actually a front end located at cloudflare.com.
And the
by
next one,
performing the
what I'm
reverse
gonna
DNS,
tell you
we
is
can
this.
see the actual name of that server appear.
Is that
When you receive the results of a
1723 is
DNS
open, but that's an
query,
encrypted
those are
channel.
often provided to you
LDAP
through a
is
server
open,
that is
that's
caching
encrypted.
that information.
So
But occasionally
what
you would like
this
to
is
get
my
information
judgment,
from the
guys,
primary
all
DNS server
testing
for
I
that
see for
domain.
all the servers.
We refer to that
It's gonna
primary
be
device
422.
as the authoritative server.
Okay,
That means
because
that
422 can be
DNS
used
server
as
is the
a
one
backup.
that is the authority for
In
that
other words,
entire
why is
DNS
422?
zone.
That's
If you're
something that
accessing a
really
DNS
should not
server
open
or
to
receiving a
begin with.
result from a DNS
Even though it's
server that
encrypted.
is not the authority,
Port
then it
3389
may
is
not
closed. So
authoritative
it leaves
server.
you with
So it may be
1723,
a
which is a
secondary
VPN.
server that's receiving
You're
a
not looking at
copy
that,
of the
that's
zone
LDAP
files
security,
from
not
the
worry about
authoritative
that.
server. But in
You
many
need to
cases,
investigate
it's
why
usually a
23 is
server that
filtered. You
caching
also
this
need to look at
information to
422.
make that DNS query
I
much
can tell you
faster.
from all the
For
other
example, I
tests,
use the NS lookup utility to
422
perform a
can be targeted for a brute force. I've seen it on too doing any other SEC Plus tests. That's what I believe that is, especially like Pen Test Plus.
All right, so that's a little sample of what you'll see when they're going through questions for that. So hopefully that'll help you out.
Yeah.
So what we'll do at this time, let's go ahead and take 10 minutes And I'll see you back, and we'll go through domain 3.
Authoritative server, there may be cached IP addresses on a non-authoritative server that are still providing incorrect information to end users. Fortunately, we can specify how long a non-authoritative server will keep that information cached. At the end of that time frame, the non-authoritative server will delete those details, and any subsequent queries for that domain name would need to go all the way to the authoritative server so that information could be cached again. We refer to the amount of time that a non-authoritative server will maintain that cache as a time to live, or a TTL. That time to live is added to the configuration file of the authoritative DNS, and it's listed as the number of seconds that that information is allowed to be cached. We can see this time to live when we perform a DNS query. For example, if you use dig to perform a query of www.professormesser.com, you can see that the results are showing 3 different IP addresses. But you'll also see that there are some numbers included on each line of those IP addresses, the number 300. This specifies that this information will only stay in a cache for 300 seconds, so you know that the IP addresses that you're resolving are going to be 5 minutes old or less. DNS commonly uses recursive DNS queries to populate those local DNS servers and cache that information so that we're able to obtain those resolutions as quickly as possible. This is part of the overall efficiencies associated with DNS and allows us to have many different DNS queries taking place, but minimize the amount of overall network traffic. The DNS server itself is the one doing all of the hard work behind the scenes. The end user never sees any of these recursive queries. And then once the original recursive query is done, we have information that's now cached on our local DNS server, and any subsequent requests for that domain name will come from our local server in the cache. Let's look at how this recursive DNS query occurs. Let's first assume that no previous queries have been made for this domain name, so nothing is hidden or stored within any caches. We start with the device making the request. We refer to this device as the resolver. This resolver is going to make a request to your local DNS server. So in this case, we're looking for the name www.professormesser.com. If your local DNS server is one that is managed by your company, or it's one that may be at a third party such as Google, that name of www.professormesser.com is not going to exist in that particular DNS database because the DNS server used by our domain is located at a different provider. So how does our local name server know where to find that particular information? Fortunately, the local DNS server is configured with a root server IP address. So the local name server is going to make a request to the root server asking for www.professormesser.com. The root server doesn't contain that information, but it does know where the .com name server is, and it provides that information to your local name server. The local name server is then going to make a request to the .com name server. The .com name server does have a record that shows where the primary DNS is for the domain professormesser.com, and it provides the answer of that IP address back to the local name server. Now the local name server knows exactly where the primary DNS server is, and it makes a direct request to the professormesser.com name server, and of course that server will know exactly the IP address for www.professormesser.com, and it will provide that information back to your local name server. Now that that information is back at the local name server, it can provide the answer back to your workstation, and it will cache that information so that any subsequent requests will simply query the local name server, and the local name server will be able to respond back immediately. DNS is a protocol that has been around for a very long time, and when it was first created, there was not a lot of work put into security of the protocol. Information for DNS is usually sent in the clear, and if someone was monitoring your DNS queries, they could at least have an idea of the services or the names of devices that you're trying to access. Another challenge is that the results that we're getting from DNS are not authenticated. So we're never quite sure if we're receiving legitimate responses from a DNS server, or if the responses that we're receiving may be from a third party or spoofed DNS server. One way to resolve this is to use DNSSEC. This is Domain Name Security Extensions, where the responses that we get from these DNS servers are digitally signed. This means that we can verify that the information that we're receiving really did come from a trusted source, and the information contained within that DNS response has not been modified by a third party somewhere along the transmission. DNSSEC does require additional changes and configurations in your DNS server, but it does provide a much more secure method of name resolution. Even though this information has now been digitally signed and we can confirm that we're receiving information from a trusted source, the information that's being sent is still in the clear, which means anybody capturing that traffic can see the host names that you're trying to access. One way to resolve this is to encrypt all of the traffic to and from the DNS server. One method of encrypting this data is through DNS over TLS, or DOT. This allows you to send the DNS traffic over a different TCP port than usual. By default, it's TCP 853, and it encrypts all of that information using very similar protocols to what we use when we are encrypting web server communication. Another form of encrypting this DNS information is to send DNS over HTTPS, or DOH. This is going to send all of that DNS information over a very standard HTTPS packet. This is the same process of communication that we use to send and receive encrypted data to a web server. And if you were to look at a packet capture, you would see traffic that looked exactly like encrypted web server traffic that's being communicated over TCP port 443. Some of the more modern browsers use DOH by default, and you may be already encrypting that DNS traffic whenever you're accessing web servers from your browser. If you were to look at the configuration file of a DNS server, you would see a number of different lines, and those lines contain one or more different types of DNS records. We refer to these as resource records, and these resource records might provide information that allows us to resolve a name from an IP address. It might contain information about a certificate that we could use to validate DNS information. It may contain aliases of host names that are stored within the DNS database, or one of many other record types. On the screen is a DNS configuration file. You'll notice there are a lot of different types of information contained within the DNS file, and in this video, we'll step through a number of these more popular DNS records. At the very top of the DNS configuration file is a Start of Authority record, or an SOA. This gives us an overview of what we will find inside of this DNS configuration. Information such as the DNS zone details, so we can see what domain this particular DNS configuration is a part of. You can see serial number information, and you can find details about retries, expirations, and how long information should be stored. One of the most common record types you will find in a DNS server is the A record, or the quad A. This record defines the IP address of a host. This is the record containing the information we need when we send a query to a DNS server. Records marked with an A are for IP version 4 addresses, so you often see the IPv4 address and the name of the device associated with that IP address. Records marked with 4As, or quad A records, are for IP version 6. This provides the same functionality with both IP version 4 and IP version 6, but the type of record is different, where IPv4 has 1A and IPv6 has 4As. This is an A record from my DNS server. You can see the name on this record is www.professormesser.com. This is an internet record. It has an A, which is referring to this address record, and then the IP address of this device, 162.159.246.164. That is the information contained within my DNS server, and if somebody queries that server for www.professormesser.com, that DNS server will return the IP address associated with that A record. Sometimes you have a single IP address that is referenced by multiple names, and we can configure this alias of names inside of our DNS server. We refer to this record type as a CNAME record. This stands for a canonical name record. So for example, you might have one server such as mail.example.com, but that same server may be providing other services and may be referenced through other names. We would include those names inside of these CNAME records. For example, you can have a chat alias, and that chat alias is pointing to mail.example.com. You can also have an FTP alias. That FTP alias is also pointing to mail.example.com. And there's a third alias of www, which is
All right,
also
everybody,
pointing
welcome back.
to that same server that's located
As
at
promised, we're going to get into domain
mail.example.com.
3.
This actually means
Domain
there will be
3.
multiple requests made if someone was
Some
to
of the
query
things that you might see
www.example.com.
as far as
The DNS
objectives
server
on
recognizes that you're looking for www, and it provides your client with the name
This time it's going to move into
mail.example.com.
incident
If you already
response
know the
and
IP address
management.
of mail.example.com, then the
So if we're
transaction
looking
is
at
over.
3.1,
But if that information is not
this is
captured
actually
in
a
the
small
machine,
domain.
a
See
separate
this?
request
It's
will
only
be
one
made to
page.
the DNS server to resolve the IP
It's
address
not a lot.
for mail.example.com.
However, there's a lot
Another important
inside
record
of
on our
these
DNS servers is
individual
the NX record. This
objectives.
stands for Mail
Okay.
Exchanger Record, and obviously this is an important record for organizations.
So let's
that need
bring
to
up
make sure
one thing
that
here.
emails
Let's
are
go.
being able to send and receive from that domain name. In this
Actually,
DNS
let me go
server,
here.
you can see there is an MX record, and it specifies
easier
that
to
the name of
bounce
the
back
mail
and
server
forth.
is mail.example.com. At this point, if you needed to send mail directly to that
I'll
mail
just bring it
server,
up on the
you would
screen
have to
here.
perform another
One thing we
name
need to
resolution to
remember, because they will
mail.example.com.
ask
So
you
as long
about
as
it
there
on
is
the
an A
exam,
record,
will be
you'll be
the
able to resolve the
cyber
IP
kill
address
chain.
associated with that mail server. On some DNS servers, you don't
Cyber
have
kill
access
chain.
to the text-based configuration file,
All right.
and all of those configuration settings need to be made in
I'll
a
drop this
web-based front end. Here's an
in
example of
chat
one of
for
those
you.
web-based front ends where we are modifying the mail record. You can see that the name is mail.
We have 7 stages of the cyber kill chain. Cyber kill
Specifics
chain
of
was
where that
created
target
by
name
Lockheed
is in the
Martin.
mail record, and you can
They
see the
understood
time
that
to
the way
live. In this
military
case, is 15
addressed
minutes on
any
this DNS
threats,
server.
it's very effective.
Another
So they
useful record
transferred
type on
over
a
the
DNS server
military
is a text record or
approach
TXT
to how
record.
that
This provides human readable
they
text
were going to
information,
resolve
and it's used
or
for many
mitigate
different purposes.
any
One of the more common uses of a text record is to
exploits.
configure
So
the
basically, that's how I
SPF
came about.
information. This stands
Alright,
for
so it's
Sender
kind of mirror
Policy
image.
Framework.
So the
This
7
is a way
stages
that
of
we
the
can tell our
cyber kill
DNS
chain.
server
First of all,
what
it comes
email
with the
servers are
reconnaissance.
authorized to send mail
At this
on
point,
our
the
behalf.
attacker, whoever
This is to
would like
prevent
to
someone
attack
else from building their own mail server and
your
sending
network,
mail
is
with
going to
your
look for
name
ways to get in.
associated with it.
What are
The
some
mail
ways that you
servers
can
that receive
look
these email
at to get
messages will
into
refer back to
anything?
the SPF
As far
record
as
that's
if you're trying to
contained
get
within your
to
DNS server
access,
in a text
what are
record,
some
and
different
they will
ways
verify if that mail really came
you will
from
be
an
looking for
authorized host.
to
These text
access
records can also be used
something
for
that you're not
DKIM.
supposed to
This is the domain
when it comes
keys
to
identified
technology?
mail, where we are digitally signing the emails that we are sending
got?
to
What
another
you got? What you
location.
got?
And when those emails are received, that digital signature can be verified. But to be able to verify that digital signature,
Okay, Charles says,
we
yep,
need the
reduce the
public
recon,
key
walk
that is
around,
associated with that signature
espionage.
itself. And the text
Okay.
record in our DNS
So
server
how
is where
would
we're going
you
to store
find?
that public
There
key.
you go.
Here
Port
is
scans.
the SPF text record and the DKIM
Okay.
text record from
How
my
would you do
DNS
port
server.
scans?
The SPF record shows professormesser.com, and it shows
Let me
specific
rephrase
mail
that for you,
server
Charles.
that
I
is
didn't ask
allowed
that
to
in the
send
right
mail
way.
on my behalf. In this case,
Is it better to
mail
do port
server at
scans
mailgun.org.
if you can get on the
And
inside
in
of the
order to
network
verify the digital
or
signatures,
from the
I also
outside?
need a DKIM text record. You can see that
Inside,
this
I'll
public
read your
key
lips.
is quite
Yep, you
long,
said
but it
inside.
is
Yeah.
all text information,
So
which makes
what
it
would
perfect
you
to put
try
inside the
to
DNS text
access
record.
if it's better to do it
Another
from the
important
inside?
record is a record that specifies where the name servers are for your particular domain.
You can run that stat too
These are
from the
obviously
inside, but
extremely
what would you
important
try to
servers,
access
especially
on
if
the
you need to
inside
perform name
to
resolution.
do a port
These
scan?
are name server records or NS records, and you can find these NS records.
Kevin says, get a
listed
job there,
as
work my way up to gain
individual
access
lines
to
that
everything.
specify
Yep, play the
where
long
those
game.
name
You know what?
servers
A lot
are
of people do
located.
play the long game.
For example, in this domain,
You can do it again
can
from
see
an
there are
employee's
two name
computer. How
servers
about the
listed.
easiest
One
thing?
is
Walk into the lobby as well and say, hey,
NS1.example.com, and
I'm
the
here
other
for a
is
job interview.
NS2.example.com.
Wi-Fi. Yep.
And the last record we'll look at is a
I
partner
believe
record or PTR.
that an organization's Wi-Fi, how they protect it, tells me a lot about where they're at as far as IT.
Domain name. For example,
Would y'all agree with that or no?
that we'd like the IP address.
At least,
Yeah.
I just believe that something
But you can
basic
also
is
perform a
Wi-Fi
reverse lookup where you're asking the DNS server
and how
to
you
provide
guard
the
it
name by
really tells a lot about how you're structured and what you're doing to protect your whole network. So if you're protecting your Wi-Fi, what things should I see if I'm trying to connect?
This DNS server, we have
You're right, it could be a honeypot.
records, 3 different
No, you're
ones
exactly
listed
right. It could run through something like that. Yeah.
www.example.com,
Correct. No SSID. That's a good one. All right. What else?
You'll notice there's a number associated with each of those, and that refers back to the IP address associated with that particular subnet. In the DNS configuration, those IP addresses are shown in reverse. So this is for the IP
No
address
default password.
192.168.23.2 is joe.example.com. 192.168.23.15 is
WPA3 Enterprise. You'll see that when you connect. Well, you mostly see WPA2 through Enterprise. 3 is Enterprise too, but it's not back. Y'all get what I'm saying. I'm just blasting right now. Okay. System starts to slow down. Yes. Elaine says it could be what type of domain, Elaine? If I'm gaining access to the Wi-Fi in the lobby, which is a community area,
Yeah. So
what type of personalized
in this video,
LAN
we're
would
going to
that
talk about NTP, or the Network Time Protocol. This is the protocol that we use
starts with a
across
G.
all of the devices
yeah,
on our network to be able to
enterprise or
synchronize their
group
clocks.
of
So if you're looking at the clock that's in your
what type of
laptop or
network?
desktop
enterprise or
computer,
group of
or
some
you're
sort.
examining log files that have
It'll be an
timestamps
enterprise, but you
switch
can LAN it out
around
as a
the
guest
firewall. All of
network.
those clocks
Yeah,
are
yeah.
perfectly
It'll come up
synchronized
to say
using the
you're on the right
Network Time
track,
Protocol.
but it'll come up to
As
say
you can
like
imagine,
a guest
having
network.
every device
But you're right,
using
it's a group
exactly the
of
same
some sort
timestamp
that you
can
put.
be critical, especially when you're
you know,
comparing log
Kim
files
says
and
this is
other
like when
information
pineapple, so
that
they
may
can
have
try to
been
steal.
taken
You
from
can do that too.
devices.
So yeah,
This is also
there's your
an
mind.
automatic
You're
process
thinking.
so that every
Right,
device
good.
can automatically
Next,
get
after you've done your
exactly the correct
reconnaissance, we
NTP
move on to the
configured. This is
weaponization
also
piece.
something that we can configure. So we might have some devices
Malware
that
or exploits are created to target those weaknesses. All right, here we go.
to work properly, we need a time server. This NTP server listens on UDP port 123, and it's responsible for responding to any time requests from your NTP clients.
There are
The
websites
NTP
out
server
there.
does not modify its own time, and if it needs to update its own time, then it needs to have a separate NTP client that then queries a
That you
different
can create
NTP
a
server.
packet.
The client is the software
All right.
that's responsible for querying the server and obtaining the latest update of time
Manipulate
information. And in some cases, we might have
packets.
both an NTP client and an NTP server on the same
There are some
device.
websites
The
where you
server
can
is handing out timestamps
create-
to any of your NTP clients, and then if you need to update the time on that device,
There it
a
is,
separate
Scapy.
NTP
That's what I was
client
looking
on
for.
that device will
Scapy.
perform the same
So you'll see
query to a
this. It's
different
called
NTP
what is a
server.
Scapy
Some
library and what it
organizations will
does.
query an external
You may
NTP
see this
server
on the
to
exam,
provide
that
time
term.
information. But if
Scapy is a
NTP
program
for
written
your
in
organization,
Python that
you may
allows
choose to
the
have your
user to
own
send,
NTP server. You would then
capture,
configure all of the NTP clients on
analyze,
your network
and
to
generate
your own internal
network packets.
NTP servers.
Basically, if I'm in a
By
man,
default, NTP
they don't
sends
use man in the
information
middle
in the
anymore.
clear.
It's called an
For all
on-path.
the time of day, it's not something
But
that's
if
generated
I'm
private.
on path,
So it's common to send
taking
this
your
in a
traffic,
non-encrypted
I can
form across the
regenerate
network.
the packets
Time
after
can be
I
an
have
important security concern.
crafted them
For example,
or
Kerberos is
changed
often used
something
to
in
authenticate
it.
devices
I can
on a
use it
Microsoft Windows
as
network.
get
But
ready to
Kerberos
weaponize
won't
that
work
packet.
if the client and the
Okay,
server's
so
timestamps are
you'll
off
see
by more
this.
than 5 minutes. So you
Scapy
could
is also
potentially
in
cause
Kali
a denial of
Linux.
service by providing the wrong time
Okay,
to
where
all
you
the
can
clients
recraft a
on this
packet.
network. For that reason,
The
we need some way
functionalities
to
allow, among
enhance
other
the
things, to
response
create,
that we're getting from
probe,
these
scan,
NTP
and attack
servers.
networks.
One way to do this is by using network time security, or
What is the structure of
NTS.
this
This
library?
adds a level
You
of
have to import the
authentication so
packet,
that we know the response that we're
import
getting back from the servers
package
is one that can be
utility.
trusted. To use network time security, we need an additional
You import
device
it
on
in the
the network
Scapy,
known as the network time
and then
security
from here,
exchange server.
you can
This
change
is the server that's responsible
anything
for
about that
authenticating the
packet.
clients and making sure that they all have a
All right,
cookie
slightly.
that can be used to
Now, you can
perform the
also
NTP query.
add
So
a
this now
payload
turns into a two-step
to the packet
process.
if you
We
want.
first obtain the authentication
And there's a lot of
details
other different
and then
things you can
provide
do.
that cookie
You can
to
display the
NTP
contents
server.
of it, where it's
Here's a
going.
better view of
The
this.
port
We first
numbers,
have
you
a
can change the
handshake
port
that
number in the
occurs
packet.
between the
There's a
client
lot of
and
stuff you can do with
NTP
Scapy.
exchange
Wow.
server. And then we can
Okay.
request a
Very
copy of
interesting,
that
huh,
server
Lane?
and
Yeah.
receive it in that
So you
response.
could
From
craft
this point,
what
we
you
can
want
perform an
and
NTP
resend it.
request to an NTP
All
server.
right, so now you have that active.
Cookie information
It
shows
is
that we
a
have
shady
authenticated
tool.
to the
It's in
key
Kali
exchange server.
Linux. You can
We can
practice
then
on it.
receive the
Of
NTP
course, on
response,
practice on the
and we
network.
now know
Just,
that we have a valid timestamp.
I have to
from
say
a
the public
trusted
announcement,
server.
right? Of course,
With a
test this on the
local
network that
NTP
belongs to you.
server,
You've got
we can
permission.
get
These are
accuracies
right.
Yeah.
down to around 10
Boom, there you go.
milliseconds. But in some
Legal
environments,
jumbo,
we need very
mumbo
precise
jumbo.
time synchronization, and we can
But
do
be
that
careful,
by using
yeah. But
precision
build a
time
lab or
protocol,
something where you
or
can do it.
PTP. This is a
All right.
hardware-based
So let's
time
get back to the
synchronization that
receiver
provides
kill chain.
granularity down to the nanosecond. This is especially important for industrial uses where you need to make sure that the timestamps across all of
All right,
those
so once you
devices
do that,
are very precise.
you gotta figure out the
PTP often
delivery.
requires a separate piece of hardware that is separate
Malicious
from our
payload is
operating
sent via
system and
what?
any of our
Phishing email.
applications. That means
You
that
may
it has
have.
its own operating system.
What's the website
It can
you
run
send
without
everybody
any
to?
delays
What type of
from any
website
type
is it?
of
You
third-party
steal all our
process.
stuff. You send
It can
everybody to.
provide the most accurate
Oh.
timestamps for all of your devices.
Starts with a W.
Oh,
Round sounds like water. There you go.
water.
Water.
Oh, okay.
Yep. So you can send them to that website or inject physical media
A
into an
VPN
open
is
port
a virtual private
USB
network.
drive key logger.
That is a way
And
of
then
taking
now the
information
exploitation is
normally
about
be
to
sent
happen because
across
the payload
network
activates.
clear, and
Now
encrypting
it's
all of
going
that
it's
data
going
so
to
that we're then
exploit
able to send it over
the
public
flaw that
networks
you've
such as the
identified in
internet. If you're
reconnaissance.
using a VPN from your workstation,
It's going to
then you're
exploit the
probably
flaw,
connecting to a
and
VPN
here we go.
concentrator. This is a functionality that's usually
Now
built
it
into
will
our
install
firewalls
because
that
it had
allows us
to
encrypt
exploit
and decrypt
the
information
flaw
from that concentrator.
in order
This
to
means
be
we
able
can
to
encrypt information,
install.
send it
These
across
are
that
the
public
ones.
network, and on the concentrator,
There's a
we
question
can
on the
decrypt
CYSA
that
exam
information
that
and
kind
send it on
of
its
will
way.
mess you up
This might be a
because
piece
it
of
will
hardware that is
ask you what would
specifically
you do
designed
next.
for this
People think the
encryption and
weaponization is
decryption
down here
process,
in the
or all of
delivery.
this may
It's not.
occur within software that
You
we
get
can
it ready.
install on an existing
You figure
server.
out how you're going to deliver
VPN
it.
clients can be
Once you
installed
deliver
on
it,
many
it
different
takes
operating
an
systems,
action
and
or
some
something for the
operating
user
systems
to
may
do
include
to
VPN
activate.
clients built into
Now
the
it's
operating system
exploiting
itself.
the
If you're
vulnerability
using a client to
in
site
order
VPN,
to
then you have
install.
software that's installed onto the client
Okay.
workstation, and that client
Now
workstation will be communicating
it
back to a
beacons,
central site.
or
For
now
example,
it
you
will
could be using a
report
laptop
back
at a
to
coffee
a
shop,
command
and
and
you may want
control.
to enable this VPN functionality so
And
that
now
you can
it's on
communicate
actions
securely to
on
a
the objective.
concentrator that's located on your corporate
Time
network.
on target.
Sometimes this is software
What's
that you
the
can
plan?
manually enable
What
or
is their
disable depending
ultimate
on when you
goal?
might want to use it.
That's the
And some
action
VPN
of the
software can be
objective.
configured as an always-on
Right? So
connection.
whoever's
So you
doing this
turn
to
on your
you
laptop and log in,
is
it
now
has
going to
already
account for
created
we're
the
in,
VPN
let's go.
connection back to your
And they're
corporate
going
network.
straight for
So
what
you
they
would either
need.
start
Yeah.
your VPN software
Okay.
and enable it manually, or that software would be
This also gives you a
automatically
summary. I'll
loaded.
put the
And
link
as soon as you
in
begin sending
the
information across the
chat
network,
for
all
you
of that communication will be
for
encrypted.
you to
When that
peruse
encrypted data is
this.
received by your VPN
All right,
concentrator,
and they even
it
have a
decrypts
cheat
that
sheet
data
here for
and
you
then sends
as well.
all of that into your internal network. Whenever
All right.
you're sending information back to the laptop, it
Cool.
reverses this process where
Cool.
it takes the information from the corporate
Then you
network,
actually have the
encrypts
diamond
it,
model of
sends it across
intrusion.
the internet, and it will
That's the
decrypt
diamond
that
model.
into your
What's the
laptop.
key word when we say
Another
diamond
type of
model?
VPN
It allows you
connectivity is between
to.
different sites. This is a site-to-site VPN where all of the communication between one site and another is encrypted over this VPN tunnel.
Starts
Okay.
repeat.
This is something that's commonly
Oh.
used
Pivot.
as an always-on connection,
Yep.
so that you can
If
be
you see
sure
the
that
diamond
everything
model
between those locations
as
will
a
always be
selection and a
encrypted.
question,
This is
and
usually
you see
built
the word
into an
pivot,
existing firewall.
yeah,
So you
it's
turn on
diamond
the
model.
VPN concentrator function
Allows you to
on
go
each
any
firewall
direction
at each
at any
location,
time
and you
to
would
get
have
additional
all of the data
information
sent between these locations traverse this encrypted tunnel.
about the
Of course, the
intrusion.
concentrators will be decrypting this data on either side of the connection, so the users at the different remote sites have no idea that this data is being encrypted between the two locations.
Porter's diamond model
Instead
framework.
of installing a separate piece
It
of
explains
software
why
just
specific
for this
industries
VPN
in the
connectivity,
nation become
your
international.
organization
Blah,
may
blah, blah,
choose
blah,
to
blah.
use clientless
Basically,
VPNs that don't
they
require
use this
a
here for
specific
firms,
VPN client.
right? So
This
the
is
diamond
something
model,
that
reason why I
usually
showed
runs
it,
inside
this
the
is not
browser
new.
using HTML5. This is the
They've taken
hypertext
this from
markup
a
language
business
version 5.
perspective,
HTML5
and
allows
they
us to
put
use
it
an
in
application programming interface to be able to interact with the browser.
a
And one of
cyber
those
perspective.
APIs is a web cryptography API, which allows us to run a a VPN client.
So there's nothing
inside of
new
our
that's come
browser
out. They
without
just
using a
adapted it.
separate client. This means we don't have to install any additional software. We just visit the
As you can
appropriate
see
web
right there.
page and the VPN software within
All right.
that API.
So you have adversary,
provides that encrypted tunnel.
infrastructure,
All you have to do
target,
is make
and
sure you're
capability.
using an
Now, if I
HTML5
remember
compliant
correctly,
browser, and you'll
I
be
do
able to use
remember
the
some
supply
type
this
of
functionality
verbiage on
within
a
the browser
possible
on your system.
question that related to
The
the
administrator
diamond.
of your VPN system may
And the
configure
question
connectivity
related to
in a
what
number
are
of
the
different
four
ways. One of these
areas?
methods may be through the use of a
Okay.
full tunnel.
I don't know if
A
there's
full
an
VPN
acronym
tunnel
for that.
means that all traffic that's being sent out of your
TIAC?
machine is traversing that VPN
Or-
tunnel.
K.
It is encrypted
Oh,
on the
K.
other side where the concentrator is located.
C-A-I-T.
Your local
K.
machine doesn't make any special
Ah,
forwarding
okay. Yeah,
decisions
yeah.
where
See,
some
you just
traffic
made
is
that
sent
up.
through the
Listen.
tunnel and other traffic is
Capability,
not. Instead,
adversary,
everything is being
infrastructure,
sent over
target.
that VPN
So if you know the
connection.
target,
In some
what was being
cases, though,
infiltrated,
the
and that's
administrator
all
of
you
your
knew.
VPN may configure
And the next
a
piece of
split
information
tunnel.
from your
A split
investigation
tunnel
goes to
means that some
infrastructure, and now
traffic
you're
will be
pivoting
sent
that way.
over the encrypted
Then from
VPN,
here, you might
but
have
other
found the
types of
capability.
traffic, perhaps
Now you know
something
the
that is not
adversary, or you
related
may
to
know the
your
adversary
environment,
and
is
the
sent
target, so you can
outside
go in
of
either
the
direction.
VPN connection. So let's take the scenario
All
where
right.
we're using a VPN. We are
Cool.
connected over this VPN
Any questions
connection
on
to a
that?
VPN concentrator that's at our corporate office. But we might
And of
also
course, we
want
know
to
the minor
communicate
attack
to a
framework
web
is a
server that's on the
direct
internet
reflection
that's not part of our
of.
organization. So you might want to connect to my server at professormesser.com.
Oh,
This means that normally traffic that's destined for your corporate network would go from your
The
remote
minor
users
attack
workstation to
framework
the
is a
VPN
direct
concentrator
reflection of
that
these
would then
three
be
initials.
decrypted and sent
Two
to
of them
the
are the same.
inside of your corporate network. But if traffic needs to go
no.
to professormesser.com,
Correct.
that traffic
TTP.
still needs to traverse that
TTP.
VPN tunnel. It is
This is something
decrypted
that the good
at
person and the
concentrator,
bad
just
person
like all
will
of the
use
other VPN
to
traffic,
help
and then
defend
is redirected
and
to the
or
internet and to
penetrate
the
test a
external
network.
web server. Any communication
Uh-huh.
back to the client.
You
would
also
then
have
need
the
to go back
open
to the
source security
concentrator
testing
and then be
methodology
sent back
manual.
through
This
that
is a
VPN tunnel.
baseline of
With a
security
split
testing
tunnel, we
and
can
the things that
avoid
you
that
are able to
additional
do
routing that occurs
in
when you're
these minor
talking to a
tasks. And of
third-party
course,
website.
OWASP.
So now at the remote users
Yep,
workstation,
techniques,
we
tactics, and
effectively have two
procedurals.
different
Thank you very
paths.
much.
We have our VPN tunnel
Next, you'll
back to
have
our corporate
OWASP.
network,
OWASP is
and then
Open
we would have
Web
a separate path that
Application,
is used for other
right?
third-party
Security
traffic.
program.
If we want to communicate to our corporate network,
Right.
we would send that traffic
So
through the
this is going to
VPN
test all your
as usual to our VPN
applications and
concentrator,
web
which then
portals and
decrypts the
things
traffic
belonging to
and
the
sends it to our
web.
corporate network. But if we also, at the same time, would like
As
to
we move down to
communicate
3.2, detection and
professormesser.com,
analysis,
we
you have
would then, at
indicators
the
of
remote
compromise.
user's workstation, simply send that traffic as
Indicators
normal.
of compromise
The
are
VPN
anything that you
client
can
would
gather
recognize that we're talking to a
that
device
may come
that's
through
not
a
part of
couple
our
of
corporate network,
publications. Have
and
you
would
heard
directly
this?
send that traffic to the third-party website without traversing the VPN tunnel.
You ever
And
heard of
of course,
sticks
the
and
traffic
taxi?
back to our device
Sticks
would
and
also not
taxis,
use
yeah.
that VPN
Sticks
connection.
and
This
taxi.
means
Who
we
wants to
can
look that up?
continue to have an encrypted and secure connection to our corporate network, but use a more efficient
This
process
is a
of
cool
communicating
thing.
to third-party
I think they
websites.
have removed it from the exam. This relates to cybersecurity protocol and incidents, how to respond. There you go. It's a way to share security
If you've done
information.
anything in networking relating to
Okay.
switches, routers, firewalls, or other devices, then you
It won't
probably
stick
connected
in my
over the
mind.
network
Ah, I
to
like that.
a terminal or
Nice play on
console.
words.
To do this over an
So with
encrypted
sticks
channel,
and
you use a
taxi,
protocol known
mom
as
joke.
SSH.
Oh yes, you got a
This
mom
is
joke.
secure shell.
Gotta
This
get
allows you
rockets
to
for
use
that.
this terminal screen
Finally, you got a mom
device,
joke
but
out
all
of
Yeah.
of the traffic sent over the network is
Lord,
encrypted.
it only took
This means
12
you
weeks.
can enter your username, your
It only
password,
took
and
12
all
weeks
other
to get a
information,
mom joke.
and no one else will be able to capture that traffic
Backed
and
up with the
save any of
laughs.
that important data. Secure Shell
But it
operates
happened. Way to
using
go.
TCP port 22.
Only 12
It's
weeks. Yep,
designed
only
to
took 12 weeks.
replace a protocol
But
known as
here, with the
Telnet,
indicators
which
of
uses
compromise,
TCP port
now you're gonna look for
23.
these different
Telnet is
feeds
very
like
similar in
sticks,
operation
taxi,
to SSH. It provides this console-based
MITRE.
remote
MITRE does
device,
a really good
but it
job
provides no encryption, and that's
by
why the best
attaching,
practice is to always use SSH
successful
and to not use Telnet. Working at a command line
exploits,
is
can I
useful,
say that?
especially on
Right?
devices that
Or
support it, but
vulnerabilities,
occasionally you
things
need
that
to be
were
able to provide
used
remote
against the
access to
company.
a graphical
Uh,
front end. You can do
Experts,
that
what's
by
the one where it's
using
a
some
panel
type
of
remote sharing
industry
software so that
experts
you can
that
be
help
at a remote location
give you a
and still
baseline?
see and operate the
Ah.
same desktop as
It's a
someone
group
who's
of
sitting directly in
industry
front of that computer.
experts,
If this
industry
is a Windows
community
computer, then
experts
Is
you're
it
using
professional?
that
ORP,
give you
which
some
is
type of
Microsoft
benchmark.
Remote Desktop Protocol.
I mean, a
It
baseline?
allows you to connect to a Windows machine.
I
and
knew.
able
I
to
just asked y'all
access and
yesterday.
use the
I said, don't
front end
forget this.
as
That's
it
the Look,
you were in front of the actual
community of experts.
keyboard. If this is a Windows computer that you're connecting to,
I know.
RDP or Microsoft Remote Desktop Protocol. This allows you to
They
remotely
always
control a Windows
update
machine
these
from
benchmarks
another Windows machine across
for
the network, or
baselining
by using
security
remote desktop
for
protocol clients that are
your
available for nearly any
infrastructure.
other operating
It's a
system. Another
community
option
of
for remote
experts.
control of a device
What
would
is
be
the
to use
name of this
VNC, or
organization?
virtual network computing. This uses a protocol known as
See ya,
RFB, or remote
Mr.
frame buffer.
T from
This is
the
very similar
top
in function to
row.
Microsoft's RDP,
This man
but
gets
the VNC functionality
bazooks.
can be run
Whoop,
on
whoop.
many different operating systems.
There you go. So
If you're
remember,
part of the help
CI
desk or
Center
support
for
team and you need
Internet
a way to
Security.
remotely connect and
Yeah,
control
there you
any
go.
of these remote desktops,
Way to go.
you're probably going to be using RDP
All right.
or VNC.
So this is where you're going to get your
Sometimes
indicators
you
of
need to be able
compromise.
to make
System
changes
slowing
to
down.
hundreds
File
or even
names
thousands
changing.
of different devices.
File
You could
structure
automate this at the
changing.
command line using
DLL
scripts and batch
files
files,
changing.
but because
Root
this operates at the
capabilities
command
changing.
line, you don't
That
have
kind
a
of
lot of
stuff.
control over the process.
So
and you
in
have to
this,
run
it'll
into
tell you what to look
problems.
for.
For
Then
that
you have
reason, you
things
might
that
want
will
to
help you
use
get
a
the
more
evidence.
automated method of
You have to
controlling
have
that
that chain of
device
custody,
using an
validate the
API
integrity. We've
or
already talked about
application programming
hashing,
interface. Using an
preservation
API,
of
you
the
can connect
data,
and control a device using
Center
the
for
language
Ants.
that device would expect. This also allows
Things
us
might
to
be on
automate
legal
the
hold,
process and set up
grab all
additional
your
tasks if we
logs,
need to do
because
any
when it
type
comes
of
down
error
to it,
handling.
you have to do
If you
containment,
happen to be in the same physical location as
eradication,
the device, you
and
may be
recovery.
able to plug in a cable and directly connect to the
Containment,
device. With switches, routers,
eradication,
and other
and
infrastructure
recovery
devices,
for
you might even
incident
have a separate port on the
response.
front labeled console. That
So
console
in this,
allows
you
you
have
to
to find
connect
out what
through
is
a
your
serial
scope.
connection so that you can
Meaning,
plug in your
what was
RJ45 serial, a
compromised
DB9
that we
serial
know of
connection,
in this
or a
attack?
more modern USB
Single
connection
pane of
to be able
glass.
to
You
gain
got to look
access
past
to
it
that
across
system.
everything to
The
see
console
what
is
was
also a perfect
compromised.
solution if you lose network connectivity to the device.
What are we looking
If you're
at?
not
Then
able
you
to
have to
ping
say, okay,
or
now that it
SSH
was
into the
compromised,
device, you can
what was
always
the
connect your
impact of
console
that
cable
compromise?
and directly
Are there any
communicate with the system.
subsystems, users,
These consoles
connection,
are commonly text-based
broken
interfaces,
authentication,
so you need to know the command
right?
line interface
Now
for
we
that
need to
particular
isolate.
device. These console connections
Isolate
are commonly serial
the
connections, so
item
you'll need
and
a
or the
laptop
network.
or desktop computer with a
Begin your
serial port,
remediation.
or we will
You
need
may
an
have to
adapter that
reimage
can
and
convert
then
between
add any
USB
compensating
to a serial
tools.
connection. Instead of
Now, what's the
individually
compensating
connecting to
tool?
devices, some organizations
This
will
tricks
create
up a
a
lot
jump
of folks.
server that allows you to connect to one
Compensating tool.
device. From there, you can jump to the other devices within that particular organization. This means from your external device,
We can give you an
you
example
use some
of a
type of
compensating
VPN
tool,
tunnel
not
or
just the
SSH
definition.
connection to initially
Just to
connect
help
to
some
the jump
folks.
server. Because this jump server is often an externally facing device where anyone
I
on
give
the
you a minute
internet
to think
could
about it.
potentially
Wait,
connect
what
to that
was the
system, this
what was
needs
the
to be
question?
very hardened. We need to be sure that we're using
Internet.
authentication
Wait, what was
with
the?
multiple factors to be able to prevent anyone from brute forcing their way into that jump server.
There you go.
For external
Instead of
site,
just
we would use
updating
some type of
cables,
third-party
we just
software,
update the
VPN,
entire
SSH,
firewall.
or some
That's a
other secure
compensating
mechanism
control.
to gain access to
Why
the
do
jump
this
server.
when we can just
Once
drop
we're on the
this
jump
security
server, we can
camera
then connect
instead
to all of the
of
other
security
devices
guard?
within that organization without having to
Up
set
to
up separate
security.
connections for each individual
Still in the same
device.
wheelhouse,
We
but
obviously
you're
need to be sure that this jump
evaluating
server is
how can
always
we
kept
make
up to
this
date with security
better,
patches, and that we provide a
or
high
how
level
can it
of
fill a
authentication
gap
to
while
prevent
we're
any
making
third
it better.
parties from gaining access
All
to
right,
the
way to go.
inside of this private network.
All right.
The console connection on a switch, router, or other device allows us
With all
to
of these
directly
tools,
connect.
you have
Very often, we're located
the
in a
preparation
different
through
network at a
post-incident.
different facility, and we
How
still
to
need
fix
some
something.
way to
Yeah,
gain
how do we
access to
fix
these
something
systems.
but save
Fortunately,
money?
most
Correct.
devices support
You have to look at different
management, where
angles
you can
while
assign
you're
an IP
attacking
address to
that one
device
thing.
and then connect
You
to
know?
it using SSH or web-based.
All right.
Sometimes this
In
inbound
preparation
management
for
is
your
a
incident
separate
response
interface
plan,
on
get
the
your
device.
tools together
Other times
and
it's
your
built
playbooks.
into other interfaces
Now,
that
we
already
did a
exist on
walkthrough.
that device. When configuring
Is it
that
the actual
switch,
answer?
router, or other
The
device,
perfect
you would
answer?
provide
No,
a
it's not the
VPN
actual answer.
management IP
But they're going to give you
address,
some selections on the
subnet mask, and
exam
other
to
important
help
networking
and to
details.
pick the right
From
answer.
that point forward, you can connect to
So,
this device
a
across the
compensating
network.
control. All right,
Usually
the
this
front
device
door is
has
broke.
a web server running internally to the device,
Physical
or maybe
security.
using an
Well, when did the
SSH
door break?
server so that
Sometime
we can
yesterday.
connect
It
from
just
our
won't stop.
SSH
The key
client.
card won't work.
Here's an
Dang.
example of a
See,
switch that
what we
not
need
only
to
has a
address is the
serial
broken door.
console connection that you can directly
We
connect to,
had a
but it also has
rule-based
separate
system that allowed
10
people to
1000
tap and
management
enter.
interface.
That is now
This is the
been
interface that you would
compromised.
assign an IP
So the
address, and then you would
compensating
connect your
control
network
to
directly
keep the
that
door
interface.
operational
From
is
that
to
point,
put a
they can
security
simply
guard.
reference the IP address and be able to connect to the
ID,
device
please.
across the network.
ID, please. ID,
If
please,
in-band
right?
management is using
Until we
an
get it
IP address
fixed.
that
That's
we
the
connect to
compensate.
through our existing network, then
Right.
out-band
At least
management is using
everybody's
a
locked out.
serial
So you're
interface
still
that does
secure.
not use our
Well, it just
existing
keeps
network.
spinning, Kevin. It
Common
doesn't
like
lock.
this
It
would
doesn't
be
stop.
something like
Can't
a
stop, won't stop.
separate management or console interface that we
Or
plug
fingerprint.
into using that serial connection.
So in that, you have to know your playbooks. Where can we find a playbook? When we
The
say
separate
playbook or
console
run book,
COM
where
port
is it?
on the device also allows us to connect a modem. So
Now,
we
this
might
is,
use a
remember, we
standard
did this
phone
to
line,
make people
connect
so
a
they're
modem
not
to
John
that phone
Wayne's.
line and be able to dial into that device.
Where's it stored
even
at?
when the network happens to be down.
We're all in the
In
call
some
center.
organizations, you can even install a COM server, so you can dial into
Elaine
the
notices
server, and from that
there's
server,
something
you can
wrong.
jump to
He
other
has to.
devices.
We're all
through
in
that
the
COM server
SOC
connection.
center. Excuse me.
You would need to look
Responding
at
to
your
stuff.
switch, router, or other device to see if there is a
Where
serial
is the
connection or
playbook
console
and
connection
or run book
that you
for
can
him
either
to
directly connect to
immediately
or use a
refer
modem
to?
to dial into from a remote
Where are
site.
they located? They may be. That's a service level agreement. Okay, keywords.
In IT security,
You're working
there are
in a
number of different
security
topics to consider, and in
operations
this
center.
video, we'll look at
It's
some
in
of
the
those security
computer.
concepts.
Where?
We'll start with the
Oh.
categorization of data. If data is transferred across the network, we
In a
refer to that
folder.
as data in transit.
You know what? I like that
Sometimes
answer.
we refer to
Because
as
this is
data
why.
in motion. Anytime you have
If you're working in a
information
seam or a
transferred over
sewer,
wired or wireless
it may be in
network,
a
you have data in
folder
transit.
inside
Most of
the
devices that
source
we use in
system.
our network infrastructure are designed to get
Off to
information
the
from one
left,
place to another.
it may
not
say, here's your
necessarily
indicators of
to that data.
compromise. Elaine, we need you to look into it. He
A
clicks on
switch,
it.
a router, or some
When he
other
clicks on it,
device,
it refreshes the left side of the browser or the right. Says, here's your playbook or run book. Would you like to go through it real quick? He clicks on it.
Other devices, such as
Here's how he
firewalls,
responds. Here's his run book.
These are systems that are designed
Oh,
to monitor
and it
the
walks him
traffic
through each
inside
step
the
he should be
traffic
doing
forwarded
before he has to
and then
escalate,
look inside the traffic
or it
itself
will
to
help
make sure
him
that none of
mitigate.
that information
One of those
is
two are gonna
malicious.
happen.
We might also
So
include
that's where it's stored at. So
data
perfect
encryption
answer.
through the use
In a
of
folder
encryption.
on the computer.
Very common encryption types
You just gotta figure out where.
TLS, which is transport
All
layer
right.
security, and IPsec.
Then you have to do tabletop exercises. We're sitting here
If you're saving
like we're doing right
information to
now.
a hard drive, an SSD,
Let's make
or some
believe.
type of storage device, we refer to that data as
Let's make
data
believe there's an
access.
intrusion.
What
There's a
kind
guy
of
that's
data
called
is
Steve
data
Miller walking around with a hoodie. What would you do if you saw this person?
This means that if someone
I'd ask him, do you want to work here?
drive,
Wrong answer. What else should we do?
files, but they
Like,
have no idea what
I'd
that
call security?
actually is.
Yes, perfect answer.
Some different
What if
types
he's
of
not
data
harmed?
at
What if
rest
he's
encryption
harmless?
would
I
include
didn't
the
think about
entire
that.
disk,
Like, these are just the
full
tabletop
disk
exercises.
encryption. You might
We're talking
encrypt
about
one
it,
single
right?
part of a database,
The
or
data.
an entire database of information,
Nope.
or you might encrypt individual files.
Then you
or
actually
folders
do
of files
the
within
training.
an operating system.
Now you
In
actually
most
step
cases,
up. You
we're
let people
applying
know.
different
This is
security
what we've come
policies
down
the
to.
data
This is
that
what
we're
we've
storing
agreed on.
these
These are
devices.
people we're
For
gonna
example,
call.
we might create
Let's put
access
this in
control
action
lists
and
or
go.
ACLs that would determine
Mr.
what
Miller, we
users
need you to
have
walk through the front
access
door as if
and
you
what
are
access to a
hostile,
particular type
and
of
we
data.
will actually
This
put
would
this
allow
into.
the system
This is a test.
administrator or the owner of the data to
Just to
determine
see if people are gonna do what you said you were gonna do at the tabletop
security
exercise.
controls are usually part
Put
of
it
the
in play.
operating system, and we can apply
All right,
it to
then
any
you
data
add this to
that
your
might be
business kind of
at rest.
continuity. That
One of the
is
challenges
sort of like your
with
SOP that y'all were talking
is
about.
maintaining
Standard
the
operating
control
procedure.
and
Yeah.
That's your
management
business
of all of the
continuity
different
plan. Your
encryption keys and certificates.
And then
We refer
put
to
this
the
in your
policies
disaster
and control
recovery as
of
well.
all of these
Now, what
different
you'll see is the
certificates
BC
as a public
and the
key
DR,
infrastructure,
they go hand in hand.
PKI.
Why?
If you're creating digital certificates,
If you make a change in one, you got to make the change in the other.
Security, you'll want to
Why?
rely on the policies you
Why?
configure as part of your PKI. As you can imagine, a PKI
Gotta get
is
things
not
back
a
to
small part
working.
of your security
And
infrastructure.
coincidentally,
There's usually quite a bit of work that goes into the creation
sometimes
of
the
PKI,
BC
and there's
is
often
nothing.
changes
The
and
the
updates
disaster
to policy
recovery
as time
plan
goes on.
works
Many
off what
organizations
you have
will
in the
be
business
building out
continuity
their
plan.
public key infrastructure when they start adding encryption
It's
keys
just a
to
more
web
heightened
servers,
awareness
or
of what we have to
signing
do
public certificates to individual
immediately.
users or individual
Right?
devices. The PKI
Then the
becomes a
post-incident
requirement
activities,
for maintaining and
forensics
managing all
analysis,
of
do
these
a root
different
cause
security
analysis.
assets for
This
the
is when
entire
people sit back
organization.
and they get their
One
feelings
challenge
hurt in
that many
a room
organizations
because
have
they feel
is
like people
applying a
are
level
coming
of
down on
trust
them.
towards
Well, it wouldn't have happened if you wouldn't have had that, would have
One
fixed
way
that broken
they
door a
can
month
sign
ago.
this trust
Who are you
is
trying to
through
tell
a
I ain't
digital
fixed the door?
certificate.
Don't you know that part's on backward? Well, you should have told somebody. What?
Central certificate
Like,
authority, and that's what adds the trust to these
you know,
individual certificates that are then deployed to
in a
users.
root cause analysis,
Instead of having
everybody
a
has to have an
centralized
open
some
perspective.
organizations will use
Should
a
be attacking
distributed
somebody
form of
else. It's
trust
kind of
called
like,
a web
could the
of
door
trust.
have had
With a web of
contributed
trust, if A
to
trusts B and B trusts C, then A
the
can
vulnerability
also trust C. This process
or the
of
exploit?
creating
Yeah,
certificates,
honestly, it could have.
authority, and
Is there anything we
providing
could have did
digital
different?
signatures for those certificates
Well, I
is
guess so.
often
Maybe I
built
could have
into
contacted
simple
somebody
operating
earlier or
systems.
whatnot,
For example,
right?
the
It's
certificate
not a
process
finger
built
pointing
into
situation. You're trying to
Windows
figure out how to
domain
make things
services.
better.
There are many third-party options that you
Right.
use for
Spider-Man
managing
pointing at the
operating
3
systems.
multiverse Spider-Man metaverse.
So the more common way to provide this trust in an organization is through the use of a
Let's
certificate.
see. Charles says
This
BC is what you
centralized
do regularly.
authority that
PR
all
is what you would
certificates
do to
start
get
from.
back to.
This means
Correct.
if anything
I like the way you
is
said
signed
that.
ultimately by this
Where you go?
centralized
You're
authority,
such a poet.
you can trust it anywhere
You're
in
such,
your
it's such a
organization.
poet, Mr.
Some
Miller.
organizations will build their own certificate authority within their
And then you go
organization.
for your
Other
lessons
times they
learned.
may use a third party
Your
as an
lessons
independent
learned.
authority. Whether
Finger
the CA
snaps.
is a trusted internal
Such a
resource or
poet.
it's a trusted third
All
party
right.
resource, the CA is
That's
responsible
domain
for
3.
the
How
trust
y'all
that we
feeling?
have in all of the certificates that we create.
Koalas
And
have
since the
smooth
certificate
brains.
authority is digitally signing all of these certificates, anyone can examine a
Dropping
certificate,
knowledge
see
on
who
us about
signed the
koalas.
certificate, and then determine if that is a
That's
signature
true.
that they can
And they
therefore
poop
trust.
square. What?
On the internet,
Wait a
it's useful
minute.
to have a third party
They-
provide trust. That way, anyone in the
No,
world
they don't.
can reference that certificate authority
Y'all made that
and
up.
know that there's a trust associated with those digital certificates. But if
Koalas
all of your
poop in a
devices and
square.
users are within your own
They
organization,
won't eat
you can create
eucalyptus
your own
off
certificate authority. This
a
means your
plate.
internal
They have to
certificate
pick it
authority
off
will
the
be
tree to
self-signing
know
all
it
of
is
the certificates that are created.
It's
This
wombats.
means you can get public off-the-shelf software to build your own certificate authority.
Oh, the
And then you can
wombats.
start signing your
Poop
own
squares. That is
certificates
still
within your
crazy.
organization. And as long
I don't
as
care
all
what
of the
animal.
users
An
in your
animal can
organization
poop
trust the
squares?
CA, they can
Oh my
therefore
God.
trust any of the certificates created by that same CA.
Capybaras.
When we store important data on our
What?
systems, we need to be
How
sure
did we
that
get here?
only the
It's very
authorized
interesting.
users are able to access
It's
that
very
data.
interesting.
This is something that is a common issue for all the types of data that we use
Oh my God.
across all of
All
the
right.
different systems.
So obviously y'all don't have any questions about
This is
domain
complicated
3,
by the fact
but
that
we've
data
created
is
more
residing
questions
anywhere.
about
It could be on a
animals
local
that poop
computer,
in
it could be on a central web
shapes.
server, or it could be stored in the cloud. This data
We
can
know
also
what's
be
more
accessed
intriguing
by many
to us
different
right now.
individuals
So
who have
we've
different
obviously
rights
went
and
down that
permissions
road.
to that data.
All right.
Some of this data may need to be accessed by customers or contractors,
That is too
or
funny.
you may need
Oh my
internal
gosh.
users to gain access to that
I
data.
needed that laugh
We also
today,
need
y'all.
to be sure that we have controls
Okay.
in place to prevent any unauthorized
The crazy
users
things we
gaining
talk about.
access to that data. The process
All right, let's
of
go ahead
managing
and
permissions
take.
and access to that data
Well,
is
let's do
referred to
this.
as
I need to set up
IAM,
this.
Identity and Access Management. This involves creating
Jeopardy.
an access control to that data to ensure
So let's
that
say
only
see at the
users
top of the hour.
access the information that
Fair?
they really need
Yeah.
to perform their
All right.
job. We need to be sure we have proper authentication in place so that we can verify that
I got you,
those
Mike.
are accessing the data, and we need to be sure that we provide authorization for the data once those users gain access to the network. And of course, there needs to be a way to track and monitor access to the data so that we're able to audit and understand exactly who accessed that information at any particular time. An important characteristic of identity and access management is the concept of least privilege. Least privilege is the concept that a user will only have the rights and permissions that are necessary to access the information they need to perform their job function, and no additional access would be granted. This is one of the reasons that we don't assign administrator access to every system that's on the network. We need to be sure that we are limiting how much access a user might have to an application or to data, and we need to be sure that the applications that we're using have just the right access for that particular job function. If you give users too much access to data, for example, give everyone administrator access, then everyone would be able to access any type of data at any time and be able to control it in any way they would like. That would obviously be a significant security concern, and it's one of the reasons that least privilege is an important concept in identity and access management. One way to provide this least privilege is through the process of a role-based access control. Most organizations will separate individuals into separate roles. You might have a shipping and receiving department, there might be a manager of that shipping and receiving department, and there might be a vice president that manages not only shipping and receiving, but also the accounting department. Each one of those users has a particular role within the organization, and their rights and permissions will be different depending on their role. With role-based access control, the administrator of the network determines what type of role an individual might have and what permissions might be associated with that individual role. The administrator would then assign users to each of those role definitions. So there might be a shipping and receiving role for the people performing those functions. There might be a manager role for shipping and receiving, and there might be a vice president role that handles many different aspects of the data across the entire organization. In Windows, we provide this role-based access control through the use of groups. We would create a separate group for each one of those different roles, and then we would assign users to those Windows groups. Another way to limit access to data is through the use of a geographic restriction. This means that we would identify where a user happens to be, and then we can assign different rights and permissions based on where they may be located. This can sometimes be done with an IP address. If somebody's connecting over a VPN, they might be assigned an internal IP address, and we might provide them with the rights and permissions that are expected for someone that's connected to our local network. But if they're connecting from a different state or a different country, we might want to change the type of permissions that user might have. IP addresses are not always the most accurate, so there might be other ways to determine a geographic location for a user. For example, we can use GPS or the global positioning system to determine where a person might be in the world. If GPS is not available, we might want to use the name of the wireless network where someone's located, and often we can determine the location of the access point to determine where the user might be. Once we know a user's location, we can then start assigning rights and permissions to where that user may be located. We refer to this as geofencing. Geofencing takes into account where a user might be and then allows or disallows access to information based on a physical location. For example, certain data within the organization might be very sensitive, and you may only be able to view that information if you happen to be located in the corporate headquarters building itself. If you're outside of the building, you may not have access to that data. Many organizations will supplement their physical security through the use of cameras. Sometimes we refer to this as CCTV for closed circuit television. This is a very common security technology and one that is implemented in nearly every organization. Some of the more modern cameras can not only provide motion detection, so you know if anyone happens to be in a particular area, but they might also be able to read license tags or be able to identify a user based on facial recognition. Usually there are many different cameras deployed in locations around a building or a campus, and all of those cameras are networked back to one central point where they can store this information over a long period of time. This allows the administrator to go back in time and view every video feed that may have captured information during a particular time frame. And if we're talking about physical security, we're also going to talk about door locks. A conventional lock uses a physical key to be able to gain access, and it may include additional security through the use of a deadbolt. Larger environments might have electronic readers where you would put in a personal identification code to gain access to a door, or there might be a token-based access such as the RFID badge associated with this electronic reader. Or we might not use the badge at all and instead focus on characteristics of a person such as a handprint, a fingerprint, or a retina scan. And in some cases, we combine these together to create multiple factors of authentication. So you might use a badge to be able to badge in, but then also include a personal identification number that someone would not have if they simply found your badge lying on the ground. Many of us are very familiar with the process of authenticating. We put in a username, a password, sometimes there's an additional authentication factor, and that provides us access to a system. But behind the scenes, there is a lot more happening. So let's dive into the process of authentication. The process of authentication uses something called the AAA framework. We'll look at all three of the A's associated with the AAA framework in a moment. But first, we start with a piece of information that everyone has access to, and that would be the identification that we use when we're logging in. This is often our username, it might be an email address, but it's information that is usually available to pretty much everyone. This is public information. And just because someone happens to know our email address or happens to know our login name does not give them access to our systems. The first A in the AAA framework is authentication. This is the process where you prove that you are really who you say you are. This is often done with some type of private information, such as a password or some other type of authentication factor. Once you go through the authentication process and you prove that you are who you say you are, we now need to be sure that you're provided the access associated with that particular user. This is provided through the second A in the AAA framework, authorization. We need to be sure that you're provided the proper access to files, directories, or areas of the network based on who you say you are. And of course, we need to be sure that we track the people that are logging in and the people that are logging out. We do that through the third A in the AAA framework, or accounting. We want to be sure that we document when someone logs in and logs out. We also want to be sure that we document when someone does not complete the authentication process properly. There might also be other pieces of information associated with identification, authentication, or authorization that we might also store as part of this accounting process. There may be many different processes that occur behind the scenes when you provide your username and password. But let's look at a very common scenario where we're logging into a VPN concentrator from somewhere out on the internet from our laptop. We will need to send this VPN concentrator information about who we are. We need to provide a username, a password, or some other type of authentication factor. This is usually sent to a AAA server, which contains all of this username information, stored passwords in a protected form, and anything else that can help prove that we really are the person we say we are. If the information that we've provided matches what's contained on the AAA server, that server will send a message back saying that those credentials have been approved. At that point, we're able to traverse the network because we've gone through the entire authentication process and we were confirmed by this AAA server. On many networks, we only have to provide that authentication information one time during the day, and from that point forward, we can access all of the resources that would normally be accessible to us. We refer to that one-time process as a single sign-on. When we sit down at our desk in the morning, we provide our username, our password, any other authentication details required, and from that point forward, for the rest of the day, we don't have to provide that information again. We obviously don't want to provide that access indefinitely, so there's usually a time frame associated with this, often 24 hours. So when we step back into the office the next morning, we will probably have to go through this process again. Single sign-on is a function that is directly associated with the authentication process, and not all authentication methods support single sign-on. So you want to check with the authentication method that you're using to see what options might be available for SSO or single sign-on. One very common protocol used during the authentication process is the remote authentication dial-in user service, or RADIUS. RADIUS has been around for a very long time and is supported on many different operating systems and many different devices. And although it has the word dial-in in the name of the protocol, it is a protocol that can be used on our modern networks as well. So when someone is logging into their VPN concentrator, their concentrator may be communicating to the AAA server using the RADIUS protocol. This could also be used for other authentications, such as authenticating with a server or logging into your wireless network using 802.1x. And because RADIUS is so well supported across so many different operating systems, it's common to have this as an option on most authentication systems. So if you're installing a new VPN concentrator or new firewall, you may see RADIUS as one of the options available for authentication. Some authentication databases are effectively a list of usernames and passwords. And although that could be a useful way to store authentication details, it doesn't tell us anything about who that user might be or where they might be located. To provide additional context, we might want to use a more capable way to reference these details. For instance, we might want to use the Lightweight Directory Access Protocol, or LDAP. LDAP is a way to read and write information from a centralized directory on the network. This is very similar to a phone directory or a phone listing, where you can search for users, you can look up different departments, and you can find information based on a phone number. LDAP is also a well-established standard. It was created by the International Telecommunications Union, or ITU, and it uses a standard known as X500. The original version of this protocol was known as the Directory Access Protocol, and a lightweight version of this protocol was created, and we put the L in the front to designate this as the lightweight version. So if you're using Windows Active Directory, you're logging into an Apple Open Directory system or a Novell eDirectory, and you're probably using the Lightweight Directory Access Protocol, or LDAP. I mentioned that LDAP allows us to add additional context to a particular user or particular device. We do this by using this standard known as X.500. X500 allows us to associate attributes to a user or to a device. For example, let's say that we have a web server. Obviously, this web server has a name. It may be called Widget Web, and by itself, we know that we can use that name to reference that web server. But it would be nice to have more context about where that server was located, who owns that server, and where that server might be maintained. So we might add additional attributes to that particular server's name. For example, we could add an organizational unit name. This particular organizational unit is marketing, which means this web server is managed by the marketing department. It may be part of a larger organization known as Widget. That organization may be located in London, and it may also be part of the widget.com network. Having this additional context allows us to understand where the server might be located, who manages the server, and where we can go to find out more information about that particular device. With these attributes, we can now start to build a hierarchy of information associated with that device and all of the other devices and users in our network. We can then build a tree containing these objects that we've built in our LDAP database. We might be dividing this particular database up by different countries. These different countries might have different departments within them, and ultimately you might have individual users or individual devices that will be part of that tree. We refer to these higher level objects as containers, and the individual users and devices would be leaf objects. This means during the authentication process, we can provide a lot of context about exactly who may be logging in and where they may be associated in the overall scheme of our organization. One open standard for authentication and authorization is known as SAML. It stands for the Security Assertion Markup Language. One of the goals of SAML was to make the authentication and authorization process open so that we can then apply it to many different types of applications. One of the challenges, though, with SAML was that it was not built for mobile devices. So if we need to authenticate to a device, we may need to do that across multiple devices if we need to use them all simultaneously. The authentication flow with SAML is a little bit different than the flows we've seen earlier. There's usually three different components associated with the authentication flow. There is a resource server, there's the client, which is usually you using a browser, and there is an authorization server. When a user tries to access a resource on a server and they don't already have authentication, that resource server will redirect that client to communicate to an authorization server to be able to gain access. Username and password information is then passed to the authorization server. It's confirmed through those processes we spoke of earlier through an LDAP database or Radius. And then if that information is successful, a token is generated and provided to the client. The client then proves that they've authenticated by presenting that token to the resource server. And the server will confirm that based on the cryptographic signatures and then provide an access granted information back to the client. And one of the last authentication protocols that we'll look at is known as TACACS. This is the Terminal Access Controller Access Control System. This is another authentication protocol that's been around for quite some time. It was originally used to control access to dial-up lines over modems at ARPANET. The latest version of TACACS is known as TACACS Plus, and it's one that was very commonly associated with Cisco devices. And even today, people consider TACACS Plus to be a very Cisco-centric authentication method. However, many aspects of TACACS and TACACS Plus were made public and an open standard in 1993, and today anyone should be able to integrate TACACS Plus within their authentication system. It's very common during the authentication process to provide login details such as your username and your password. But of course, someone else could have access to that information, so very often we have other authentication factors that we need to provide. When we're adding additional factors to the authentication process, we refer to that as multi-factor authentication. This means we may need to provide a password. There might be a mobile app with a particular number that we need to provide, or we might be including GPS details that show that we're located within the corporate facility itself. Some popular multi-factor authentication factors might be something you know, that might be a password, something you have, that might be your mobile phone with the app that you're using. It might be something you are, such as a biometric reading, for example, your fingerprint, or it might be somewhere you are, which would certainly be a GPS location. One or more of those could be used during the authentication process to help prove that you are really who you say you are.
Hi, I'm Mike Chappell,
The
and I'd like
factor
to
of
welcome you
something
to our
you
course
have
on
is
preparing for
often
the
associated
Cybersecurity
with
Analyst
a
Plus exam.
TOTP. This would
The
be a
CompTIA
time-based,
Cybersecurity
one-time
Analyst
password
Plus, or
algorithm
CISA Plus,
that is
is an
integrated
intermediate
into
level
an app that you
certification
might
from
have
the
on
creators
your
of the
mobile
popular
device.
entry-level
This usually
Security
has a
Plus
secret key
certification for
associated
information
with it,
security
and it uses
professionals.
the time of day to be
CISA
able to
Plus is
provide
meant to serve
what
as
is
a middle
considered to
ground
be
between
a
Security Plus
pseudo-random
and
type of
CompTIA's
numbering
Advanced
system.
Security
This
Practitioner
number tends to
certification.
change occasionally, so
If you've
every
already
30
earned your
seconds
Security
you may
Plus
get another
certification and have around
randomized
3 or
number
4
that
years of
appears on the
experience
screen.
working in the
In
cybersecurity
reality,
field,
this is not
this
a
is a
randomized
great
number. It's a
certification
number
for you
that
to
only
advance your
seems to be
career.
random, and it's a number
As
that
you
is
work your way through this
expected by
course, you'll
both
pick up
sides
all
of the
the knowledge that
authentication
you need to
process.
earn your CISA
This is
Plus
accomplished by
certification.
creating a secret
As a
key ahead
CompTIA
of time
authorized
and then
content provider,
synchronizing both the
we're ready
client
to help
and the
you pass your
server using
certification
a
exam
protocol
on the
such
first
as the
try.
network time
I
protocol.
encourage you to pick up a
So
copy
during
of
the
my CISA
authentication
Plus study
process, you
guide
may be
to
asked
help
for
you
your
prepare for the
username,
exam
your
in conjunction
password,
with
and
this
then the
course.
code that appears in the
Through
app
my
on
books
your
and
mobile
courses
phone.
here on this site,
This is
I've
becoming
helped
a
literally
very common way
hundreds of
to
thousands of
authenticate, and
students
it's
just
one
like
that's
you
used by Google,
earn their
Facebook,
security
Microsoft, and
certifications,
many
and
other
I look forward to
organizations
doing the
to
same
add
for you.
additional factors
All
to
right,
the authentication
let's get rolling.
process. In IT security, there is a constant fight happening between the attackers and the folks that are being attacked. And one of the ways that we can learn more about our attackers is to watch the attacks themselves. One of the ways that we can do this is through the use of a honeypot. We know that these attacks are often not a human being who's typing into a keyboard interactively. Usually these are scripts or programs that are designed to attack many different systems simultaneously. So one of the things we could do is to create a virtual network with virtual servers and virtual components that would be very attractive to one of these attackers. We're effectively leaving out this virtual honey that hopefully will attract this attacker's sweet tooth. If you want to see what people are using as a honeypot, or you'd like to build your own, there are many open source versions available that you can install on your own systems. The attackers, though, are very good at determining what might be real and what might be fake. So there's a constant battle to build the best possible honeypot so that you can attract the attackers and be able to watch what they're doing during these attacks. But to make this attractive to the attacker, we need more than simply a single server or a single device. We need a number of different components. We need servers, workstations, routers, firewalls, switches, proxy servers, and anything else that can make this system seem a little more real. When we compile all of these together, we've now created a honey net. We now have a much larger deception framework. We might have the attacker start with a workstation that's part of the honey net.
All right,
Then
yeah, I
they
had to
move
take
to
care
the
of some
honey net
calls.
server.
So, sorry
and
for
then
the
we might
delay.
see if we can move them over to the honey net.
Okay, we
NAS.
are back.
These are commonly virtual
Da,
devices.
da,
We can
da.
build any
Y'all ready for the
network
jet
to be
party?
able to attract the attackers.
The jet
And you want to
party?
read more about honeypots and honey nets.
Yes, this one's gonna be
There's a
quite
wealth of
fun.
information on the internet, and a good place to start would be
We'll get as far as we can get. Don't have to finish the whole thing before lunch.
In the
But
world of IT security, a lot
we have
of
some different categories up here. We have, first of all, the process. Next, the attack. Next category, the tools, the data, and the bollards. All right. So as I see it from my screen, I have, who's gonna go first would be Charles, then Aaliyah, then Elaine. Next will be Brian, Mr. T, Kevo. I think Jesus is leaving for his test, so it'll be Martin and then Michael. All right. So here we go. So let's get your pen and paper out to see how you score yourself during here. We only do it for fun, so it's really no right or wrong, but it kind of gauges to see how you feel about the information. All right. So first up, we have Charles. Charles, what is your first selection on the board?
Let's do the tools for tree hunting.
The tool for tree hunting.
Yeah.
Events like malware
beacon infection are automatically categorized, prioritized, marked by source and destination, and matched to an investigation. What is the answer? Just the answer.
Yep, that's the definition. So what's the term that matches this? Mm-hmm. Aaliyah drops seem as the first possible answer. Charles says, what is weaponization? Elaine says, automatic incident triage. Mr. T says, endpoint detection and response. Kevin chimes in and says, SOAR. All right. So if we look at the question, let's break it down. It might change your answer, might not. It says events
No.
are being categorized
So
and prioritized.
was that the only possible answer?
Martin still sticks with seeing.
So
And it's marked by a source and a destination to match the investigation.
it wouldn't be SEAM, SOAR, or EDR, or even forensic or anything like that?
All right, so if you look at the keywords in there, that's what I see. Events, they're automatically categorized, prioritized. I can see the source IP and the destination IP, and I can match it to something. All right, lock in your answers. Here we go for 300 points. It's alerts, alarms, and alert monitoring.
Okay, so the correct answer for that was alarms and
Alert
alerts. Monitoring.
Might want an explanation of this. This was covered under SEAM and SOAR. You got that right. But you have to tweak.
All right, so
alert.
So from now on, all the questions and answer will be based on
you have to go in there and set the priority for the different types of alerts
test
that you have, and the
CompTIA test and
so you
questions
don't
and
get alert
answers.
exhaustion.
So I needed to be pertaining to
nice try.
IT or cybersecurity.
Ooh, I told you this was gonna be a little harder. Y'all didn't believe me. Boo, lame question. All right, here we go. Aaliyah, you're up next.
The attack for 2.
The attack for 2
has 8 steps and was created to defend against sophisticated cyber attacks. What is the answer? Just the answer?
Hey, take your time. We got all day. Hey, Mr. T says cyber kill chain. Elaine says the same. Charles says incident response. Kevin says cyber kill chain. right, looks like Elaine's typing. Oh, he already put it in there, kill chain. Okay, is that it? Ready for the big reveal? Oh, incident response. Okay, that's what she said. Okay, had to decipher that. Michael, I concur. Charles says, IRP is only has 6. Here we go. Lock it in. Cyber kill chain.
Yeah. How much was that? That was
I figured y'all would have had that because we just talked about it before break.
Yeah.
You're right. The kill
7.
chain has 7.
But it's the closest answer.
So there was a typo on here.
Yeah.
But y'all adjusted.
Yeah.
Yep. The phases, though. Kevin says phases. So what are the phases? Trebek is fired. Oh my God. Kevin's gonna drop it in. Shall we revisit it? But there are 7 recorded steps in the cyber kill chain.
Yeah.
All right, so while he's looking that up, Kevin will drop that in the chat in a minute. Here we go. 1, 2, 3, 4, 5, 6. Recon weaponization, delivery, exploitation,
and
installation, C2.
Actions and objectives.
Action, that's 7. 1, 2, 3. Recon intrude. There you go. Recon intrusion, exploitation, privilege escalation, lateral movement, obfuscation, malware denier, service. There you go. Yeah. So you can have those different zones, but they did mess up on this on these steps. There are 7 steps, but the phases remain. So yeah, still a typo in that one. But y'all were able to decipher most of it. So
How much was that?
all right.
That was 200.
Who's next? It'll be Elaine.
All right. All right. I'll have the process category for 400.
400. Do.
Type of IR plan that focuses on individuals who have invested roles in systems, organizations, or services impacted by an incident. What is the answer?
It's a type of IR plan, but it focuses on individuals who have invested in roles in systems, organizations, or services impacted by an incident. Elaine says stakeholders. Lessons learned, shareholders. All right, everybody locking in their answer? Shareholders, internal IR. Okay. Let's do the reveal. Stakeholder manager, you're correct.
That was 400. Yeah.
Yes. Invested roles. Yep. That is the stakeholder.
So 400.
Now, CompTIA has their way of answering questions or presenting a question. Can a shareholder be a stakeholder? Yes. So if you put shareholder, you're still right.
Yeah.
But just know, for the exam, They're looking for stakeholder because we've never said that word shareholder.
Yeah.
You get what I'm saying? But a shareholder can be a stakeholder. Good job.
So that's 400.
All right. Ryan, be easy. Which one are you picking? Attack for 300. He must be flying. He ain't telling us where he's at right now. We'll see you over. Okay. He said attack for 300.
That wasn't the question. Here is the question. Step in the kill chain that will allow remote control of a channel to manipulate the victim. What is the answer?
No problem, Jesus. I got you. Let's see. There's C2. Everybody's saying C2. It helped too because Kevin just dropped all that knowledge in the freaking chat. All right, everybody locking in. C3PO? No. All right, here we go. Big reveal. It is command and control. Good job.
That was what? 300?
All right. Next, we have Mr. T. Dr. Sarn, what you got, sir? $100. Data for 100.
Stored information about failed and successful logins, as well as other authentication log information. What is the answer?
Elaine says authentication logs. Charles says sys logs. Auth logs. All right. Let's see what we got for the big reveal.
100.
Drop it like it's hot. Security logs. Yep.
So
under your security logs, you will have your successful logins. They are called audits. That's the audits, right? Audits can tell you who's logged in, who's logged out, what time, what device they ran, all that stuff. So it's under the security log.
So security log. Okay.
All right. Good try on that one. Moving on to the next, we have Kevin. What you got, third? He takes bollards for 500.
Almost got you to say it.
Mm-hmm.
In the
event that a private key is compromised, this will need to be reviewed. Told you this will be a little harder. What?
Are we talking about a physical private key or computer private key?
Let's just assume that it's.
It's in bollards, and that sounds physical to me.
Yeah. Okay, on this one, you can do two answers. Give me one that's if it's physical or if it's a network. I'll allow 2 answers.
In the event that a private key is compromised, this will need to be reviewed. What is the
Mr.
answer?
T says check the revocation list. Revoke it off the network. Leah says key revocation list. Now, this is your private key. We know a public key, you're inviting the public in, so everybody sees that key. We're talking about the private key. It's X509 cert or key. Identity. Certificate revocation. And then if you want to, you could drop, what if it's physical? What can you put in place to, if it's a physical key, what can you put in place as a check, as a revoke the cert, OCSP? What's OCSP? Oh, okay. CRL, OSP. Gotcha. All right, lock in your answers. Here we go. I will check the certificate revocation list.
So certificate.
Yep.
Right? Okay.
Way to go. So you do have to review your certificates, but that'd be in the revocation list. So good job.
Okay.
All right.
How much was that? 500? 500.
Who is up next? That'd be Mr. Martin. Data for 400. How you might determine who created a file.
How you might determine who created a file, if it was modified, and what type of file it is. What is the answer?
Michael drops in and says hashing. That's more integrity though, right? And Malia says a digital signature.
What type of file it is?
Interesting. You want to see who the owner is, who created it, if it was modified, and the file type. Four basic things. Lane says file signature or metadata. File metadata. Interesting answers here. Anything else y'all want to add? File properties. Changes to file properties. Okay. Y'all locked in your answers?
Yeah.
Here we go. Change mod or show in Linux. I click on properties. Here we go. File
metadata. Nice.
He hit it right on the nose. It's the file metadata. When he put that in there, I was like,
Yeah.
oh, he nailed it.
How much was that one?
However, Where can we find file metadata? In the properties.
Yeah.
But it is technically file metadata tells you
Yeah.
all of these things.
Yeah, yeah.
Manalane,
Yeah.
the only one that got what, 400 on that one?
400.
Jeez, nice, nice. All right. Okay, who we got next? Mike. Which one you got?
Let me get attack for 400.
Attack for 400. Gives
analysts a comprehensive
cyber attacks.
view of cyber attacks, uncover insights, and gain knowledge of malicious activities. Its ultimate goal is mitigation. What is the answer?
So SEAM gives you a total mitigation plan? Mr. T drops into the chat and says, threat intelligence gives analysts a comprehensive view of cyber attacks, uncover insights, gain knowledge of malicious activities. Its ultimate goal is mitigation. Aaliyah says threat modeling. Charles says common vulnerability and exploits. This is something that a cyber analyst needs to have. Helps analysts. Kevin says SOAR. Security orchestration and response. Elaine says threat intelligence or unintelligence. Threat unintelligence. I know what you meant. Threat intelligence.
Yeah.
Okay. Told you I misspelled more words than anybody in the chat. I'm like, dang it. Okay. All right, y'all ready? Give you one more second to drop them in. I know y'all researching. All right, here we go. 1, 2, and 3. Leah says CV. You changed it?
CVE. But she already put that. Diamond model of intrusion analysis.
It is a diamond model. As one of the true definitions of the diamond model. That's not fair to you guys. Good guess though, because you know why? That is one of the definitions that apply to the diamond model of intrusion, because you can pivot between the 4 points.
Yeah.
Even though we specifically didn't go over it, that's what it is.
Okay.
But good guesses. Kevin says, I don't even know why I get a pen and paper out. It should be pretty easy to remember 0 points. This just makes you tougher. Remember, there's no win or lose here. The whole point of this is to get the brains going. That's all it does. Gets you thinking. That's all. Yep. All right, here we go. Jesus, you there? All right, we're rotating back up to Charles. Charles, what you got?
Do the attack for 100.
Attack for 100. A
database of attacks and techniques used by threat actors from the perspective of an attacker. What is the answer?
I know, right, Aaliyah? That's why I like this, because it makes you think. That's all it does. It gets your brain going before you actually get into the testing center. That's what it does. Brings all this stuff up of possibilities. Charles says attack framework. Aaliyah says the same. Miter. It's only a miter.
That was 100.
They not like us. Okay. Miter, I hardly know her. That little Common? Is that from Common? I used to love her. Old school joint. Alright. Miter, she wrote. I liked it. It's Miter, she wrote. Aaliyah just made another mom joke. Oh my God. That's 2 in a row this morning. She busted out week 12. Squabble up. She got her second mom joke. She's on something. All right, y'all ready? Here we go. It is the miter attack framework. Good job on that one. Good job. That's 100. All right. Talking about Aaliyah, she is now up next.